the planet! Hack the planet!
Shut up again!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing HackerFrogs After School today. We're doing HackerFrogs free hacking. We're hacking all the things. So let's talk about what we're going to be covering on today's stream. Today is Wednesday, May 27th, 2026, and we're going to be covering 4 topics as is usual on this stream. The first thing we're going to be doing today is a warm-up topic, AI basics. We're going to be learning about AI because everybody's talking about AI. So that's going to be the first hour of today's stream. In the second hour, we're going to be doing PicoCTF 2026 general challenges. We're going to be doing some demonstrations of these tech CTF challenges, and we're going to be showing everybody how to do them step by step. That's the second hour of today's stream. In the third hour, we're going to be doing HackerFrogs After School. We're coming near the end of our digital forensics course, and we're going to be teaching everybody how to do memory forensics today with the volatility software. So that's going to be the third hour of today's stream. In the fourth hour, and probably the fifth hour, and maybe the sixth hour, we're going to be doing TryHackMe Intro to OT/ICS. So ICS stands for Industrial Control Systems, and we're going to be talking about the implications of security in those operational technology industrial control systems with the module from TryHackMe. So without further ado, let's get into the first topic for today's stream. I'll put 60 minutes on the clock and we'll get started into our warm-up topic. So let me just set up the timer and we'll get going. And while we're doing this topic, I think we can put on a little bit of background music. So let me go ahead and put the background music on. And Ganik, hello, nice to see you here. What is up? Okay, that music might be a little bit loud. Let me turn it down a bit. And let's get started. Okay, so what we're doing for our warm-up topic is we're going to be taking a look at an AI course. So this is the AI building course, and you can find it over here if you want to follow along with what we're doing today. So what does it say? Show off your skills. The course content is free of charge, but if you'd like to improve your CV, purchase an electronic shareable certificate. I mean, I'm not going to, but if you are interested in doing that, you can go ahead and do that. And let's see. Okay, so what's going on here? So this is the Building AI course, and well, I mean, we got to the end of the Understanding AI course. So what are we doing over here? So there's going to be 6 chapters. No, 5 chapters in this course. So there's Getting Started with AI, Dealing with Uncertainty, Machine Learning, Neural Networks, and the conclusion. So let's go ahead and get started with the first chapter, Getting Started with AI. Let's go ahead and go into there. So what's this? So Chapter 1, Why AI Matters. So in this course, we're going to take you on a journey towards your first implementable AI idea and give you the tools required to make it a reality. The path begins by looking into the algorithms that make artificial intelligence methods possible. But before we start, we wanted to take a brief moment to discuss why AI matters in the first place, okay? So let's see if we can make this a little bit bigger. So in a word, relevance. Artificial intelligence, or at least narrow AI that handles only one task, is already part of our daily lives. When we search online, use our smartphone to take and edit a picture, ask Siri or Alexa for a recommendation, or use GPS navigation, we're relying on AI methods. Danilo, hello, nice to see you here, and welcome to the stream. So we're just taking a little AI course as part of our warm-up today. In practice, that means we're already surrounded by AI, and this influence only looks set to grow. So, a lot of the modern conveniences in today's tech space is thanks to AI, even though most people only identify AI as ChatGPT or Grok or Claude. But in fact, there's a lot of other AI that is being used in our daily lives that is not those things. Okay, as you will find in this course, we think this influence is a good thing so long as we're smart about it. After all, AI is simply a collection of methods for solving problems. We think that AI is too important to leave to just the tech experts. That's why our goal is to empower as many people as possible to be part of creating meaningful AI solutions to real-world problems. Building AI is for anyone who wants to improve their AI-related vocabulary and skills, including non-programmers and people who can program in Python. People who can program in Python, that's us. Okay. By taking the course, you'll learn more about what makes different AI methods possible and where and how these methods can be applied in real life, helping you to communicate about AI and take part in AI-related projects. For some of you, this course will also be the first step towards actually being able to program these methods. From here, you'll be able to go on to more advanced courses that really delve into programming. By finishing this course, you'll be able to start formulating a realistic, useful, and implementable AI idea, which can become your own project that you can develop as far as you want. What AI looks like in real life. So here are just a few examples of where you can find AI methods at work. These are all real-life cases that we will look at in more detail in later chapters. So the first thing is content recommendation. So a lot of people don't really think of this as AI, but the way that things are recommended to us are absolutely an AI method. So if you've ever been recommended videos on YouTube, or videos on TikTok, or music on Spotify, there's an AI underneath the hood doing the work there. All of us familiar with content recommendation systems think Netflix and YouTube, but as it turns out, commonly used recommendation algorithms are good, for example, at recommending popular shows like dramas, while downplaying other areas like educational or scientific content. But this can be changed, increasing people's exposure to broader types of content. Okay, and there's online shopping. So, I mean, when we talk about online shopping, oh, okay, I think I understand. So, when people make purchases, they also recommend other things to be purchased. So people who purchase one thing might also commonly purchase some other things. So that's also covered by AI. So much choice, so little time, but how do you make browsing tens of thousands of items convenient, especially on a mobile phone? Machine learning methods can recommend products based on the purchase behavior of an individual user as well as other customers who purchase similar products. And we've got online support. Nearly half of social media users have encountered online bullying or harassment online. Machine learning methods based on natural language natural language processing (NLP) can be used to provide scalable legal and psychological first aid online. Psychological first aid. Okay, and we've got resource mapping. What kind of critical infrastructure like schools exist in your countries? In your country and a lot of places in the world, the answer is not sure, but having an accurate and comprehensive map of infrastructure is a key tool for measuring and improving quality. Neural networks can be trained to identify features from looking at high-resolution satellite images in order to identify buildings and create accurate maps. Okay, Danilo says, great to hear from you again. I'm from Ecuador in Latin America, and I work as a SOC analyst. I really enjoy your content. It helps me to learn about cybersecurity and improve my English. No worries, Danilo, and I hope you can have a good time on today's stream as well. So we also have AI in waste sorting. So reduce, reuse, recycle, we're all familiar with the mantra, and most of us dutifully sort our waste. But what happens after that? The fact that a lot of what we recycle still ends up in the landfill or is incinerated. But using neural networks can enable robots to sort waste and improve recycling rates. And Iceman, hello, nice to see you here. Which country's flag is that? That is that Ecuador? Oh, okay. Alright, so your AI idea. For learning purposes, this is probably the most important example of real-life AI in this course, simply because it's yours. The optional project in Chapter 5 is the endpoint of your Elements of AI journey, and the final stepping stone after which you'll be able to present your idea to the wider AI community. Okay, so working with AI in real life. People can encounter and use AI in their work in many different ways. Here are 3 common examples. You can work as a professional who has good understanding of AI methods and the ability to ideate realistic solutions that involve an AI component. The ability to combine an understanding of AI with knowledge from other fields can lead to valuable results, even if you're not writing the code yourself. Those who are more interested in the infrastructure behind what makes AI systems tick can work, for example, as data engineers. A data engineer makes sure that the data flows where it is needed and is of the right type and quality for specific AI solutions. It's crucial with real-life, large-scale, production-ready AI systems to get that supporting infrastructure right so that you can avoid the so-called garbage in, garbage out problem. Those who have deep understanding of AI algorithms can apply these methods to real-life problems with job titles such as AI developer, AI engineer, or data scientist. To excel in this area, you need to have a proven track record in applying AI to different types of problems. In addition to the technical skills, you'll need to know what's possible, what's not possible, and often most importantly, when you should apply AI in the first place and when not. The world seems to be full of people who claim to be AI evangelists, but what modern companies are looking for is people who can make things happen and who actually understand what AI is and what it isn't capable of. And that's exactly why this course can help. What this course can help with. Read Miko's career story as an example here. What is this? Okay, so if anybody wants to take a look at this link, I'll leave it in the chat. So if you're aiming for a career in data science, you may wish to consider applying, for instance, to the University of Helsinki's master's program in data science. Okay, so how this course takes you towards real-life AI solutions. It takes a lot of steps to get to the level where you can actually create AI methods. This course helps to bridge the gap between total beginner course in AI, like the Elements of AI Introduction to AI, and more advanced machine learning AI courses available now. One of our goals with this course is to help introduce you to the broader AI community. For that reason, Chapter 5 is an optional project suitable for all of the students taking this course, whatever your level. And Harold, hello, nice to see you here. How are you doing? I'm doing alright. I'm just starting my stream and doing our warm-up topic. So with our final project, we want to encourage you to step out of the sandbox and get your hands dirty with some real-world AI programming, even if it's simple, and we'll introduce you to GitHub, the leading code sharing platform where everyone in the AI community comes together to collaborate. For those of you who don't program, you can still take part by following the template of questions in Chapter 5 to begin outlining a problem that could be potentially solved by AI, and the kinds of methods that might work to solve it. We ultimately hope that you can share your ideas in your workplace or connect with potential developers and see your idea come to life. We'll also be offering a chance to showcase ideas and the projects that grow out of this course in our GitHub gallery. We'll get the necessary tools to help you prepare you for submitting an idea by completing this course and the accompanying exercises. Okay, so apparently we have 3 different levels of exercises in this course. So every exercise has 3 levels of difficulty, and you can try whichever level suits you best. We encourage you to challenge yourself and at least take a look at the next level of exercises. And Xiao Lao Shu, hello, nice to see you. What is up? Welcome to the stream. Okay, there's beginner level. No programming language needed. There will be multiple choice questions only. Intermediate. Some Python programming knowledge needed. Exercises include modifying existing code or writing simple code. And advanced. You should be comfortable with programming in Python. Exercises include writing code in Python. So please also note that in the context of this course, advanced means, for example, a computer science student or someone who has done some programming in Python before, not a programming professional. This is still meant to be an introductory course to AI programming, and professional programmers may be better served with one of the existing machine learning courses. Okay, so let's see. Xiao says, thanks, nothing much. I got addicted to home labbing. That's awesome. There's nothing like understanding a system like building it yourself. Okay, don't worry if you can't decide which difficulty level to choose. You can always switch the level at any point during the course, and you can mix and match the levels in any way you like. See the requirements to earn special honors by passing the course on the different levels below. Okay, so in order to pass the course, you'll need to complete at least 19 of the exercises out of a total of 21, and answer 50% of those correctly. As mentioned above, each exercise has 3 difficulty options: beginner, intermediate, and advanced. Doing any one of these levels will count as completing the exercise. Intermediate and advanced exercises require programming. If you complete enough intermediate or advanced exercises, this will be mentioned on your certificate of completion. You'll earn intermediate honors by completing 19 of the exercises, with at least 14 of those being at the intermediate level. Okay, Harold, hello, nice to see you here. What are we reading? So we're currently doing this course over here. It's called Building AI from the Elements of AI website. So this one over here. So you'll earn advanced honors by completing 19 of the exercises, with at least 14 of them being at the advanced level. You can submit your answers to multiple choice questions only once. For the programming exercises, you can test your answers for correctness as many times as you want. When your answer is correct, all of the tests will pass and your answer will be automatically submitted. If you want to brush up or learn some Python in order to try the intermediate or advanced challenges, we recommend Python for Everyone, a textbook and course available on multiple platforms, How to Think Like a Computer Scientist, or Codecademy's Python course, which is not free. Okay, David Ferguson, hello, nice to see you here. How the programming exercises work. So our goal has been to create a simple programming method, which means everything can be done in your browser without having to install your own developing environment. Common Python libraries will also be available, like NumPy. The programming exercises will only be available on the desktop version of this course. The editor we use isn't supported on mobile browsers. Desktop version of this course. So get a hang of the difficulty levels with the exercise below. This exercise is not included in the course grading. Okay, you also looked up quantum computing. I mean, we have looked up quantum computing kind of recently, and I might be taking a course on quantum computing after this. Because, well, a lot of people are asking about quantum computing. So let's see, we got introduction to the exercises, beginner, intermediate, and advanced. Beginner level exercises are the only ones you can do on a mobile device. The exercises at this level are multiple choice questions you can view and complete. Intermediate and advanced exercises only on a computer. It is possible to move freely between the different difficulty levels. You can complete exercises in any order. However, you will notice that the course is much easier if you don't skip exercises. We encourage you to give the more difficult exercises a try if you have even a slight idea of coding. Okay, so how are you planning to proceed with the course? So we're probably gonna try to complete the intermediate or advanced level exercises, but we'll see what happens. Okay, Xiao says it's fun. Quantum computing math gets weird though. I'm currently doing a bit of research with it. I mean, I'm not really a math person, but I would like to understand at least some of the concepts behind quantum computing because people are going to be talking about it more and more in the future. Okay, your answer is correct. Great. And then we'll go on to the next section. So next section is optimization. And I think, oh, we've also got the intermediate level here as well. So intermediate and advanced, let's take a look. Okay, the intermediate exercise involves coding, either so that you can get to modify existing code and write your own, or in a few cases, answer multiple choice questions involving code examples. Remember that you can move freely between the different difficulty levels. Okay, so let's just continue. Go ahead and experiment with the code editor below. You can't break it. The exercise doesn't give you points, so you don't have to worry about losing any points. So you can reset the code window, and you can also run the code. Okay? If your code contains any print statements, you should see the output in the separate output window. GPO says basically 1 + 1 = 2, and that's all you need to know. Well, I hope it's that easy. Okay, so what do we got? So you can define your own functions. Define greet, print welcome plus name. Go ahead and enter your own name in the variable name to get a warm welcome from us. Okay, so if our name is, I don't know, the Shy Hat, and then we run greet with the name, I guess we should see welcome the Shy Hat. So run this, and the output is down here. Welcome the Shy Hat. So what's the difference between between the run button and the test button? Test if your code meets the criteria for a correct answer. Okay, so we'll test it as well. Test result. Assertion error, welcome the Shy Hat. Welcome to building AI. So they want building AI. Well, okay. Let's go ahead and fill that in then to exactly what they want. So this will be to building AI. Okay, and then we'll test it. Okay, test passed. All right. We hope you're having fun. Remember that finding errors in your code or debugging is a bit like detective work. Okay, the test button will test your code. Okay, and let's see. Some of the exercises involve graphical output. These exercises have an additional plot button, like below. Since we don't cover graphics and plotting in this course, the code that does the plotting is usually hidden behind the scenes, so you only need to click the plot button to see the outcome. Note that it may sometimes take a while to see the outcome when you click plot for the first time. Okay, so what does this do? So import numpy as np, import matplotlib.pyplot as plt, and then we're going to generate a 30 by 50 array of random numbers. Okay, the following code that will plot the numbers as colors would normally be hidden from you. So again, you don't have to worry about it. Try clicking on the plot button to see the outcome. Okay, so let's click on plot. So I'm guessing that our output is going to be down here in the graph. Oh, that's interesting. So for each one of these, Each one of these random numbers, they've assigned a color to it and created this pattern below, and well, this pattern over here. Okay, and let's see. So finally, once you've passed all the tests, your answer will be automatically submitted. As a summary, remember to click on the test button often because the test feedback will help you debug the code and only correct answers will be submitted. When the answer is submitted, you'll get the points from the exercise, except for this one. Okay, so if we go up here and we click on test, what are they looking for? Yeah, I'm really not too sure what they're looking for here. But anyways, we'll just continue. Okay, so they want welcome to building AI, so we can just adjust this over here. So this is the intermediate exercise. But we do want to take a look at what the advanced exercises look like. I may or may not be able to do them. I mean, I've got an amount of coding experience with Python, but I wouldn't say that I'm super proficient with it. Okay, good job experimenting. Go ahead and see the advanced exercise as well. Okay, so let's just go up to the top and we'll try out the advanced exercise. Over here. Okay, welcome to your first coding exercise. Advanced exercise differ from intermediate ones mainly by the amount of code we provide to start with. In the intermediate exercises, you're mostly expected to modify a small part of the code, while in advanced exercises, you may need to start it from scratch. So in all the coding exercises, the usual tricks apply. Read the problem statement and the comments in the provided code carefully. Write code in small bits and run often. Feel free to add print statements to see what's going on in the code. Click on the test button as many times as possible, well, as needed, okay? If the code template contains functions, it's important to keep their input and output formats the way they're given. The same applies to print statements in case the program is expected produce print. The same applies to print statements in case the program is expected to produce printed output. So there's a typo over here. Okay, solving this exercise will be helpful in the first actual exercise, exercise 1. So consider using this up as an opportunity to warm up. So your task is to define a function that returns the so-called factorial for any non-negative integer n. The factorial is defined as 1 times 2 times something until n. So for example, factorial 5 is 1 times 2 times 3 times 4 times 5 equals 120. Okay, so the simplest way to compute the factorial is to use a recursive function, or in other words, a function that calls itself as a factorial equals n times factorial n minus 1. Oh, okay. And quantum computing sounds scary. I mean, it does sound kind of scary. Okay, so there's an ad running on Twitch right now, so we will take a break and we'll take. Let's go ahead and put on some birds. So we'll take a minute break, and in the meantime, you can watch this robin having a little bath. Okay, see you in about 60 seconds, everybody. Okay, let's put the birds away and get back to what we're supposed to be doing here. So the recursion should terminate at factorial 0, so equals 1, so that we don't create an infinite loop. So define factorial if n equals 0, return 1, else return none. Else return none. Replace this with the recursive call. Okay, so define factorial n if n is equal to 0, return 1, else return factorial n minus 1. And then we need to update the n minus 1. We also need to update n inside of this inside of the function as well, don't we? Else n equals n minus 1. Do we want to do this before the return, or do we want to do this after the return? I mean, if we do the return first... No. So we just run the thing again. So if we update n... If we update n here... And it... and factorial n should equal n times factorial n minus 1. So we put it over here. N times n minus 1. Okay, and then we'll run this. I think... Okay, so this does seem to be working out so far. So this would be like 1 times... Okay. Let's take a look at here. So factorial 6. So factorial 6 should be 1 times 2 times 3 times 4 times 5 times 6. Actually, so I think I've got the wrong answer here. So 1 times 2 is... Let's just separate these into little groups. So 5 times 6 is 30, and then 3 times 4 is 12, and 1 times 2 is 2. So it's going to be, let's say 2 times 30 is 60, 60 times 12. So 60 times 12. 60 times 12 is 2 times 0 is 0, and then 2 times 6 is 12. And then place a 0 in front, and then 1 times 0 is 0, and 1 times 6 is 6. So this is 600 plus, so this should be, yeah. So this should be 720. 720? But we've got the wrong answer here. So factorial 6, this should print 720, but it doesn't. It prints 15. So n times factorial n minus 1. Okay, so if n equals 0, then return true. Else, n equals n minus 1. Actually, maybe we just need to omit this. Okay, and then run it. We got 720. This is what they want. Okay, test it. Okay, and what do we got? Test cases 5 out of 5. Have a look at the beginner and intermediate exercises. Okay, so I think we can move on to the next section now that we've done the beginner, advanced, and intermediate ones. Optimization. So let's see, optimization exercise 1 and exercise 2. So you may ask, what do we mean when we talk about AI? It is something very advanced like deep. Is it something very advanced like deep neural networks and complex algorithms, or is it just a fancy word for any software? Unfortunately, we can't give a precise definition. Why? Because there isn't one. The field of AI doesn't have a commonly agreed definition. We discussed this topic in some detail in Chapter 1 of the Introduction to AI course. We argued that it's often the way the technology is being used, rather than the technology itself, that determines whether it's appropriate to call it AI or not. Okay, a case in point, optimization. A good example of something that can be AI or not, depending on the use case, is optimization. As you will see, some optimization algorithms are very, very simple and can be implemented in a few lines of code. However, we will argue that the outcome may be considered intelligent behavior, which many of us would call AI without qualms. In an Introduction to AI Chapter 2, we showed you various brain teasers or puzzles like the Towers of Hanoi or the Chicken Crossing puzzle that can be formulated as search problems and solved in a straightforward manner by finding a path from the starting point to the goal. When we have the superpower of programming, we can scale up to much bigger problems than before when we have to solve everything with a pencil and paper. Okay, than before when we had to solve everything with a pencil and paper. We will start with the absolute classic, the so-called traveling salesperson problem, or TSP, for those who love TLAs, 3-letter acronyms. Okay, so then an example optimization task. Imagine that you've been assigned to plan the route of a container ship loaded with pineapples. The ship starts in Panama, loaded with delicious fair trade pineapples. There are 4 other ports: New York, Casablanca, Amsterdam, and Helsinki, where pineapple-craving citizens are eagerly waiting. The ship must visit each of the 4 destination ports exactly once, but the order in which they visit each port is free. Okay, the goal is to minimize the carbon emissions, which means that a shorter route is better than a longer one. Okay, and here's the container vessel over here. To solve this problem, it is enough to list all the possible routes that start from Panama and visit each of the other ports exactly once, calculate the carbon emissions for each route, and print out the one with the least emissions. Let's consider each stage separately, starting from listing all the possible alternatives. The term used by programmers is enumerate. So we'll first enumerate all the possible routes. So those of you who are well versed in combinatorics, the part of mathematics that deals with combinations of finite sets of objects, will know that the number of roots is 4 times 3 times 2 times 1 equals 24. Okay, so let's try the intermediate challenge for this one. So in this exercise, you will need to list all the possible routes that start from Panama and visit each of them, the other ports, exactly once. Have a look at the program further down on the page. Go ahead and run it. You'll see that the first thing it prints is Pan, AMS, 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 AMS. Nice for the sailors, but bad for pineapple lovers. Anywhere but Amsterdam. So each port is denoted by a number instead of a string. So Pan is 0, AMS is 1, and so on. It is often easier to work with integer numbers instead of strings when programming. Keep this mapping in mind when we interpret the results of the program. Fix the program by adding an if statement that checks that the route includes all of the ports. In other words, check that each of the numbers 0, 1, 2, 3, 4 are included in the list route. Do not change the print statement given in the template, although you can add more print statements for debugging purposes. So an output example would be these 5 ports here, starting with PAN, AMS, CAS, NYC, and HEL. Okay, so your values might be different, but the formatting should be identical. Okay, so what do we have here? So we got the port names in a list. So PAN, AMS, CAS, NYC, and HEL. So port equals 0. So we start with port 0. So port equals 0. So the port names are here. So port 1 equals 0. For port 2 in range 1 to 5. For port 3 in range 1 to 5. Okay, the route will be port 1, port 2, port 3, port 4, port 5. Modify this if statement to check if the route is valid. So if true, join port names I for I in route. Okay, just run main. Okay, so if we have the code as written right now and we run it, then the output is okay. So I think this is printing all of the possible routes, but the problem with these routes is that sometimes the ports are repeated more than once, which is not what we want. What we want is each port to be included exactly once. Okay, if true, do not modify this print statement. Modify this if statement to check if the route is valid. So I think what we want to do is we want to check if port names 0 and port names 1, port names 2, port names 3, and port names 4 are all in the route, then it is valid. If it doesn't have all of the items, then it's not valid. So we would do something like so 5 times 0, 1, 2, 3, 4, 5. So I don't know if this is the most efficient way to do things. I didn't go to school for programming, but so there's port names 1, port names 2, port names 3, port names 4, and I think that's all, because we start counting from 0, 0, 1, 2, 3, 4. So if these port names are in the route, then print these out. Okay, Smiling Proud, hello, nice to see you here. What are we learning? So we're learning about AI stuff, optimization. So this is kind of like a modification of the traveling salesman's problem. Anyways, let's run this test. Error, invalid syntax on line 17. Line 17, there's no line 17. Okay, so obviously my code is not correct. So we got port names up here. So 0, 1, 2, 3, 4. So port name 0 should point to the string. So we're checking to see if the strings are in here. Print. Okay. So root equals port 1, port 2, port 3, port 4, port 5. Maybe I shouldn't be using these symbols, but instead we should be using the and keyword over here. Okay, and we'll try running it again. Nothing came out of this. Modify this if statement to check if the root is valid. So I guess the other thing we could do to check if the root is valid is to make sure that there are no duplicates. So let's see, what is the better way to do this? So the root is port 1, port 2, port 3, port 4, port 5. And these are... Okay, let's do a quick search. Python, check if list has the same contents as another list. To check if two Python lists have the same contents, choose a method based on whether the order of the elements matters and if they contain duplicate items. So same contents and same order. So we don't care about the same order, but we do care about the same contents. Okay, same contents, different order with duplicates. We don't want duplicates. Okay? Same unique elements, ignoring duplicates. So if you only care if the list contains the same set of items regardless of how many times they appear in the order, convert them to Python sets. So print set list A equals set list B, output true. Okay, so I mean we can borrow this. Okay, then go back. So if set of port names equals set in root, then this should return true. Okay, and then we'll run this code. And it looks like nothing's happening. Huh, I wonder why nothing's happening here. So if set port names equals to set root, then print them out. Print port names I for I and root. Either that or something's going wrong with the code window here. So list A and list B. Actually, you know what? We can run this in our own window. Let's go ahead and code this up ourselves. Let's see. Port thing.py, and we'll borrow the code over here. Because for some reason nothing's coming out. Okay, so let's just copy everything here. Copy. And paste it into our window. And run port thing. So nothing comes out. Nothing comes out because nothing qualifies, I guess. Okay, port names. If set port names equals set root, then so do this across everything, and then all right, let's reset the code. Reset. Okay, if true, then print the things. If true, then print the things. Modify this if statement to check if the root is valid. So, I mean, we tried to check the root, if the root was valid, if the root has all of the ports in it. So set A equals set B. So the order doesn't matter. Duplicates also don't matter. But everything is coming back false. Checking if two lists are identical in Python. Okay, so Xiao says, isn't there a numpy is in method that can check this? I mean, let's look it up. NumPy is in method. Okay, let's see. The NumPy is in method is used to determine if each element of one array is present in another collection of values. It returns a Boolean array. It returns a Boolean array of the same shape as your input array, where true indicates that the element was found and false indicates it was not. So we got NumPy element, test elements, assume unique, false, inverse false. So the element is the input array whose values you want to check. The test elements are the values to test against, can be another list, can be a list tuple or another array. Assume unique, optional if set to true, NumPy assumes both inputs contain unique elements, which can speed up computation. So assume unique true, test elements, and then the element. So we can give this a try over here. So import NumPy. And then up here, so what is it called? NumPy is in. NumPy is in. So we run it with port names and then root. And assume unique is the optional parameter here, which we can set to true. Aqua, hello, nice to see you here. What is up? Okay, and then we'll try running this. Spell everything correctly, of course. The truth value of an array with more than one element is ambiguous. Use a.any or a.all. Okay, let's just remove that then. Unless we named that parameter incorrectly. So it says assume unique, optional. Ignifer, hello, nice to see you here. Okay, so is in the truth value of an array with more than one element is ambiguous. So am I using this this method incorrectly? So 1D array check. So array equals np.array. Mask is np array, and then returns an array, false, true, false, true, false. So we're checking for... Oh. Yeah, this might not be the right thing we're looking for here. Okay, isInt is a vectorized version of the Python in keyword and is significantly faster than using loops for large data sets. Floating points. So if okay, let's just ask one more question then. Actually, we're having a bit of a problem coming up with the solution here, so let's just ask the AI. Maybe it can help us out. No worries, no worries. We're all trying to come up with a solution. So we're coding in Python, and we want to check if a list has the same contents as another list, but the order of the contents may be different. What is the easiest method to check Okay, the easiest method is to sort both lists and compare them. Oh, okay. So we need to sort the lists first, and if we sort the lists, then they'll have the same contents. So you can compare them with the double equal signs. This makes sense. So is sorted the function we want to use? Or is it .sort? So sorted A, sorted B, set A, set B, sorted A, sorted B. This should work out for us. So if we go into our text editor here and then try it out, we can do so if sorted is equal to sorted, so sorted port names equals sorted root, then we can print it out. Okay, and then let's run it. Oh, nothing, still nothing comes out still, huh? That's weird. Let's just try printing this out. So right before this, we'll try printing it out as a debug. Maybe I'm using the sorted function incorrectly. Python sorted function. The sorted function is a built-in utility that takes an iterable like a list, tuple, or string and then returns a new sorted list of elements. Unlike the sort method, which modifies in place, sorted keeps the original data unchanged. I mean, this seems like it should be good. So the iterable any sequence or collection you want to sort, the function that serves as a basis for some sort comparison. Okay, so key equals length, reverse optional set it to true, the list is sorted in descending order. I mean, let's try this then. This is not very elegant, but we're just trying to get the job done. So the problem with .sort is that it modifies the actual order of the list. But let's just try printing this out first as kind of a debug. Print dot Port names I for I and root. Port names I for I and root. Oh, okay. So this all comes back false. So print the sorted port names and then print the sorted root. Let's try it like this instead. Oh, okay. So it looks like... So these are just elements. Okay, so I guess what we need to do here is we need to check if 0, 1, 2, 3, and 4 are in the list instead of the strings. So we're not actually checking for the strings, we're just checking for these integers. Okay, I think I understand what's going on here now. So we just need to check if but these are... So I guess we could do... Port numbers is a list, which is 1, 2, 3, 4, 5. So if port numbers is equal to... Oh, this is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And if port numbers equals sorted root, then it qualifies. All right. Hope this works. Inconsistent use of tabs and spaces and indentation. Okay, let's go back in. So we need to do all all tabs or all spaces whenever we're doing a Python script. Okay, so now it works. Now it works, we fixed the code. So that something tells me that it's not going to be... This isn't going to get any easier after this. Fox, hello, nice to see you here. Hope you're having a good time. Okay, so we're pretty close to the to finishing this segment of the So port numbers equals these port numbers here. So if the port numbers are equal to the sorted root, that means that we've got all of the ports inside of our root, which means it's valid. So if we go down here and then we run the test, then we get all of our possible combinations over here. Okay, and then we test to see if the code is correct. Okay, so let's see. Maybe you'd be blessed for the information that you provide for this generation. Thank you, Pulin. Okay, so the answer is correct. Test cases 1 and 1. Add the following long if statement. Add the following long if statement. If 0 in root and 1 in root and 2 in root and 3 in root and 4 in root. So this is basically what we did, only we put all of these inside of a separate list. Okay. So you don't really have to check that 0 is included because it is always included, always the starting point, but it's good programming style. Yeah, actually, we did it a little bit more complicated than it needed to be. Anyways, I think we're done. So what this teaches us, just listing the alternatives is not very useful, but at least it helps us realize that the number of routes is starting to be so big that finding the best one manually would be a chore. So there are 25 routes for 5 ports, one of which is the starting point. If some pineapples were also wanted in, say, London, it could be added in the route for 5 different positions. So the number of routes would become 5 times 24 equals 120. Yet with another destination, this number would be multiplied to 6, which would get us 6 times 120 or 720 routes, and so on. Okay, so this is the factorial that we were talking about earlier. And okay, we're going to need to move on to the next portion of today's stream because we only budgeted 60 minutes for this segment. So let's move on from here. If you want to do the same course, this is the link for you. And we're just going to move on to the next portion of today's stream, which is our demonstrations. So we're doing topic 2. Topic 3 is on deck. And hold on, let me see if I can set up my music in a different way. Just a second. How do I solve the CTF puzzle? Which CTF puzzle are you talking about? Okay, so is the ISC2 CC certificate good for you if you're a beginner? I mean, I'm not familiar with it, so I really can't provide an opinion on it, unfortunately. Okay, so we'll continue with this next time, but in the meantime, I need to do some demonstrations now. So we're going to demonstrate some challenges from PicoCTF, and these are all challenges from the PicoCTF 2026 event in the general category. Okay, when he gives you a story. Can you solve the CTF puzzle when he gives you a story? I'm not too sure what you're talking about, Fox404. Okay, so we're going to do a number of these challenges over here, and I'm going to try to demonstrate how to finish them. Let's start with this one over here. Let's see, general category. So the first challenge is called My Git. Okay, this has to do with Git repositories and how to interact with them. So let's go ahead and get started. So my Git is over here. And we'll launch, well, okay, we can launch the instance. Actually, let's close that instance. Okay, it's still going, huh? Okay. Alright everybody, this is a guided walkthrough for the My Git challenge from the general skills category as part of the PicoCTF 2026. So the description for the challenge says, I've built my own Git server with my own rules. You can clone the challenge repo using the command below. So git clone, and then we've got an SSH for Git, the Git user over here, and they also give you a password. So it says check the README to get your flag. Alright, so the first thing we want to do is we want to clone the Git repository in this case. Before we continue, let's talk about what's going on in the challenge. So this is PicoCTF 2026 My Git. In this challenge, we're asked to investigate a Git repository to read the flag. But you might be asking yourself what a Git repository is. So what we're doing is Git repository enumeration, and Git is a distributed version control system that tracks versions of files. It is used by programmers to help develop software collaboratively. So in the tech space, Git and GitHub is pretty ubiquitous. You're going to see it a lot. So let's talk about how we can do this. So the first step to solve this challenge is to clone the repository into a writable directory. So we use the git clone command to clone all the files in the repository into a local instance. So what we can do first is go back to Scilab over here, and then we need to do is we need to open up our workspace. So we'll be working inside of the Scilab workspace. So just click on that, and then that's going to start up a terminal session. So the terminal here is a Linux CLI terminal that we can use to solve this challenge. What you want to do first is you want to click into the terminal and then right-click, select this frame, and then select Open Frame in New Tab. So after you've done that, you're going to see the Scilab Academy web shell in its own browser tab, which means that you've got full screen to the terminal, which is good. So after that, we're going to create a directory to work inside of for this challenge. So we're going to make a directory called my-git, just like this. Okay, and then we're going to move into that directory, and then we're going to git clone the repository. So back at the challenge, we can close the terminal, click on Exit Workspace, and then we can copy the command. So git clone all of this, copy it, then go to the web shell, move into the correct directory, and then paste in the command. What this is going to do is it's going to contact the server, and it's going to copy all the files from the Git repository and then copy them to the local directory. When we give the command, it's going to ask us if you want to continue connecting. Type in yes, and then it's going to ask you for the password. So the password is back at the challenge over here. So it says here's the password. Copy that, then go back to the web shell, paste in the password. When you paste in the password, you won't see anything appear. This is normal. Just paste it in, hit enter, and it's going to copy all of these objects, all of these Git repository objects to this challenge directory right over here. What we want to do is we want to enter the directory, and then we want to read the README file over here, because in the challenge it said check the README to get your flag. So over here we're going to read the file, and it says my-git. If you want the flag, make sure to push the flag. So only flag.txt pushed by root at PicoCTF will be updated with the flag. Good luck. So what we want to do here is we want to do something called pushing a git commit. So we're told to push a file to the repository as the root user with the root at PicoCTF email, and we can complete this in 6 steps. So in order to push the git commit, modify the git repository, the first thing we need to do is we need to create the flag.txt file. So for example, we can create a file with the contents HackerFrogs like and subscribe, and then redirect it into flag.txt. Okay, so let's go ahead and do that. So echo HackerFrogs like and subscribe, and redirect it into flag.txt like this. So now we actually have a flag.txt file, and then we can move on to step number 2. So step number 2 is to set the git user email. So use the git command to set our email in git. So it's git config user.email root at PicoCTF. So this is the command. Git config user.email to root at PicoCTF. Okay, and then give the command. All right, so let's catch up a chat. So Poulin says big WBGM music. SysOS Master says, finally I have internet again. Heat overloaded in network switch power supply. My backup is just working. You might want to use ..local, --local with that command. I mean, this, I mean, it works in this case. So it's all right. The other thing is that we're going to be deleting this directory afterwards, and I don't think we're working with Git. I don't think we're working with Git after this, so it should be okay. Okay, so let's go ahead and where are we? Next step. So step number 3 is to set the Git username. So use a Git command again to set our username in Git. So git config user.name equals root. So user.name equals root, and then the next step is add flag.txt file to the repo. So we're going to use another git command to add the flag.txt file to the repository. So git add flag.txt. And then step 5, confirm the commit with the message. So the next thing we're going to do is we're going to use the git command to set up the commit with the message that will be attached to the commit. So it's git commit -a-m added flag.txt file. So git commit -m for message, -a, I'm pretty sure it means that include all the files in the directory. And Nitro Based, hello, nice to see you here. How are you? I'm just doing a demonstration for this challenge here. Okay, so git commit -a-m. Where is it? Git commit -a-m added flag.txt file. Okay, and it says added flag.txt file, one file changed, one insertion. And then the last thing we need to do is we need to actually push the commit. SysOS says -a equals include all tracked files, -m use the message. NitroBase says, how can I learn like you? I mean, you can start learning about CTF stuff. You can start solving a bunch of challenges. Look at this website over here if you want to get started. Okay, so the last step is step 5 over here. Push the commit to the repo. So just run git push, and that will push the commit up to the repo and actually make the changes. Lastly, use the git command to push the commit to the repository. So it's just git push. So we'll go over here, git push, and we need the password for this. So we'll get the password from the challenge, paste it in, and then we're finished. Okay, so we managed to push the commit, and in return, we get the flag. So here's your flag, PicoCTF, impersonate git. So we just need to copy the flag, go back to the challenge, and then down at the flag submission field over here, paste in the flag and click on submit flag, and then you're finished. Alright everybody, that was a guided walkthrough for the My Git challenge from PicoCTF 2026 as part of their general skills set of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, Kiwi says, is a person who truly deserves support because he provides high-quality content with explanations. What are you working on? Hello, Cypher. We're working on PicoCTF challenges from the general category. So we're just looking at these types of challenges over here. And I'm just doing some demonstrations. Okay, so that's one out of 5 challenges that we're going to be doing today. So let's take a look at the next challenges. And before we go, let me just do a bit of cleanup over here. because I've got a bunch of directories which I'm not using anymore, so it's a good thing to just get rid of them. So rm-r should be able to delete most directories. Why do I have so many of these? One more to get rid of, and then we can move on. RMRF and Headless Headhunter just rated the channel with 13 viewers. Hello, nice to see you here, Headless Headhunter, and welcome in, Raiders. What were y'all working on? And let's give a shout out to Headless Headhunter. Headless Headhunter and crew, what were you guys doing on stream? My name's the Shy Hat. I do cybersecurity content on Twitch and on YouTube, and we're currently doing some demonstrations for some of the challenges from PicoCTF 2026. Headless Headhunter says, teaching people how to get jobs and fix their resumes. I had 2 success stories on stream today, I believe. Oh, that's awesome. That's awesome. I hope you guys are open to learning about some CTF challenges. So the next one we're going to be doing is called printer shares. Okay, so printer shares, let me go ahead and get the presentation file for that, and then we can get started with the demonstration. Okay. All right, so hey everybody, this is a guided walkthrough for the Printer Shares Challenge from PicoCTF 2026 as part of their General Skills series of challenges. The description says, oops, someone accidentally sent an important file to the network printer. Can you retrieve it from the print server? And it says additional details will be available after launching your challenge instance. So the first thing we want to do is click on the Launch Instance button over here. So after the instance starts, we should get some additional information. Headless Headhunter says, half my chat is in IT. I do have to raid and run and get food, but thank you for the shout out and enjoy your stream. Yeah, thank you very much, Headless Headhunter. And if you are not following Headless Headhunter, go ahead and follow their stream. I gave them a shout out just a few minutes ago. Okay, so it says here that the printer is on this port over here. And you can also try netcat-vz-mysteriousc.picoctf.net with this particular port number. So what we're doing over here is we're contacting a server. So the server we need to contact is mysteriousc.picoctf.net, and this is the port number we need to contact. So since we were told that we need to interact with the network printer, let's talk about what's going on here. So this is PicoCTF 2026, Printer Shares. In this challenge, we're asked to check out a file on a printer share. So network accessible printers usually use the SMB protocol, and we can use the SMB client program to enumerate the printer service. So what we'd do is we'd use SMB client -L, and then let me go ahead and get the command, and then we'll discuss what's going on in the command. And thank you very much for following on Twitch, Xiao Lao Shu. Thank you. Where is it? Printer shares. Okay, so the first command that we're going to be using is called SMB client, and we're going to be using it to enumerate the server's file shares. So we're just going to grab the command and copy that. And actually, to solve this, we can actually use the Scilab web shell. So to access it, we're going to click on Open in Workspace in the challenge over here. And then we're going to right-click on the terminal, and then select this frame, and then select Open Frame in New Tab. Okay, Kiwi asks, what challenges will we overcome next time? Well, I mean, we've got a bunch of challenges that we're going to be going over today. Okay, so the PicoCTF, sorry, the Scilab Security Academy web shell is a Linux environment where we can solve challenges. So we're going to make a directory for this. Let's see, I think this challenge is called printer shares. So we're just going to make a directory called printer shares, then move into that directory. And let's talk about the command that we're going to be using. So the command that we're going to be using is smb client, which we're going to be using with the location -l mysteriousc.picoctf.net. We're going to try to log in without providing credentials, so no username password, and we're going to provide a specific port number. So this port number is 51619. So we just need to include it in the command over here. So this is the whole command right here. We're going to copy it, and then we'll give it over on our web shell. So the web shell is over here. We're going to paste in the command, and then we're going to run the command. Oh, sorry. The -l in the smb client command is the command that lets you list out the file shares. So -L. We see that there are two shares on the disk, and it says shares. So this is a disk type share with the comment public share with guests, and we have an IPC share as well. So what we need to do is we actually need to move into the actual file share. So the actual file share is called shares, and we can give another command with smb client to access the file share. So the command is this one over here. Where did I put it? Okay. So it's another smb client command. So smb client by itself, without the L, is going to try to access the share. So it's mysteriousc.picoctf.net/shares. Also with no login, and then we have to provide the port number. So the port number for this one is 51619. Your port number is probably going to be different. Please use your port number if you're doing this exercise yourself. Copy this, go back to the web shell, paste in the command. So connection refused. Oh, I didn't copy the whole. I didn't copy all of the port number. Let's do that one more time. Okay, and now it says try help to get a list of possible commands. So inside of SMB, so we're inside of the SMB protocol right now. Well, the SMB service right now. So to get a list of all the files inside the share, we would run the dir command. So the dir command is going to list out all the files on the share, and we've seen here there's a flag.txt file. So the goal of this exercise is to get access to the flag.txt file. Let's go ahead and get flag.txt to download it. Okay, and then afterwards we can just exit out of the service. Okay, we've got ads running on Twitch right now, so we're just going to take a little break and have a little bit of water. But in the meantime, we can put on the birds. Let's put on these birds. Okay, we'll be back in about 30 seconds. I just need to get myself some water. Oh, sorry I didn't see your message before, Comrade Soul, but hello and thank you for your warm greeting. Thank you. Okay, so now that we've got our flag.txt file, we see that it is in our directory here. The last thing we need to do is we need to read the file, and then we get the flag. So to complete the challenge, we just need to copy the file, go back to the challenge description, and submit the flag. Okay, then click on Submit Flag, and then we're done. Alright everybody, this was a guided walkthrough for the Printer Shares Challenge from PicoCTF 2026 as part of their general skills set of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Alright, so let's go ahead and do a little bit of cleanup over here on the web shell. And then we can get moving on to the next challenge. So let's get rid of printer shares. Okay, and then we can move on. So the next challenge, let's take a look. So the next challenge we'll do is printer shares ping CMD. Okay, so this is an interesting challenge that has a vulnerability that's usually associated with web apps, or that we see more often in web apps. But let me load up my presentation file, then we can get started. Alright everybody, this is a guided walkthrough for the Ping CMD Challenge from PicoCTF 2026 as part of their general skills set of challenges. This challenge description says, can you make the server reveal its secrets? It seems to be able to ping Google DNS, but what happens if you get a little creative with your input? Additional details will be available after launching your challenge instance, so we just need to click on Launch Instance button, the Launch Instance button over here. And then Serpentor, hello, good evening from NYC. So it's got to be a bit later over in New York City, like 6:30. But welcome to the stream, Serpentor. Okay, so it says here you can connect to the service here, ncmysteriousc.picoctf.net, and then a port number. So before we can access this, what we're going to do is we're going to access the web shell. So to access the web shell in Scilab, click on the Open in Workspace button over here, and then we'll see the terminal open up in the corner over here. But what we want to see is the terminal in full screen. So to see it in full screen, we can right-click on the terminal, and then select this frame, and then select Open Frame in New Tab. So this will open up our web shell in a separate tab, which is what we want. And from here, we can run our Linux commands. So the Linux command that they give us over here is netcat one. Okay, we're going to copy the command. Might as well exit the workspace as well. Then go over to the web shell, and then paste in the command. We can invoke Eldritch Magic, open it in a big boy tab. Yeah. Okay, paste in the command. So this is going to make, netcat is going to connect to mysteriousc.picoctf.net on port 57289. So your port number is going to be different each time you do this challenge. The program says, enter an IP address to ping. We have tight security because we only allow 8888. So if we run, we're supposed to give an IP address. If we give some other IP address, that's interesting. it still gave us a response. So what we have to take note of here is that the output from this particular application, this looks very similar to the Linux ping command. So if we actually run ping C2 127.0.0.1, oh, there's no ping on this machine. Okay, so I'll demonstrate from my Kali Linux machine. So we'll do ping C2 127.0.0.1. So we see exactly the type of output that we see from the application here. And what we, well, let's talk about what's going on in here. What does 127.1 echo hi mom do? Your first ping was local. Yeah, I mean, this ping, both pings are local because we're, well, I mean, this is local to the remote server, and this is local to my Kali Linux machine. Okay, let's talk about this. So this is PicoCTF 2026 ping CMD. In this challenge, we're asked to look at a service that's pinging Google DNS. So to people who are new to computer networking, let's just talk about what ping is. So what is the ping command? In computer networking, pinging a device means sending a packet to it to determine if there is network connectivity between the two devices. If you can successfully ping a device on the network, that means the two devices are able to communicate with each other. So when we contact the network service, the output of the command looks like the Unix Linux ping command. So it's ICMP magic. Yeah, of course it is. So anytime we see some sort of network service or some sort of web app or some sort of binary result in output that looks kind of like an OS command, like ping, it could be vulnerable to something called OS command injection. But what is OS command injection? So operating system or OS command injection is a vulnerability where arbitrary OS commands can be performed on the remote server through a network service interface. So in this case, it's through the service on that arbitrary port. OS command injection is a very serious vulnerability and can often lead to complete compromise of the remote server, and if so, the server can be used as a foothold to attack other machines on the network. So we suspect that the OS command being used by the service is the one illustrated above. So we think that the service is actually running ping-c2, which means send two pings, to whatever we supply as user input. So they're trying to get us to send it to 8.8.8.8.8, but we could put anything in here as our user input. ICMP is Internet Control Message Protocol. Yeah. Okay, so the user input in this case is the red part of the command over here. The default command that's being used by the service is what, well, we suspect it's the black command over here. So the standard OS command injection payload is to cancel the original command with a semicolon, insert the desired command, and then cancel any commands that may come afterwards with the hash symbol. So it would do semicolon to cancel this command, run the command we want, in this case it's who am I, and then comment out anything that comes afterwards with the hash symbol. So when we send our example OS command injection payload, in this case, we see that it works so that we can essentially run any commands we want. So let me go ahead and demonstrate this. So over here, we run the same netcat command. Okay, it says enter an address to ping. So we will do semicolon space, who am I, space, hash symbol. So it says that we are CTF player. So CTF player is the name of the user that's running the service. So what we can do from here is we can just run the command again, and we can start looking at what's in this directory. So we do semicolon space, then the command we want. So ls-la to see what's in this directory, and then give the hash symbol. So we see here that there is a flag.txt file in this directory. There's also a script.sh. So we suspect that script.sh is the script that's running the service. So we might as well take a look at that first. So we'll just get out of here and we'll run semicolon space cat script.sh. And this is what it's doing. So it's running a bash script. So echo n enter an IP address to ping, and then read domain. Read domain bash c ping c2 domain. So whatever we're inputting as the user input gets put into the variable called domain. So it's basically taking in our user input and feeding it into the ping command. So to finish up this exercise, we'll run this. We'll run semicolon cat flag.txt to get the goal of the exercise. So we see here we've got PicoCTF ping command exploit successful. We'll copy the flag. We'll copy it, and then we'll go back to the challenge. At the bottom of the challenge description, we can submit the flag, and then we're finished. Alright everybody, that was a guided walkthrough for the ping command challenge from PicoCTF 2026 as part of their general skills set of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Cypher says, does connecting to these delay for everyone? It took me minutes before netcat and ping worked for me. I mean, I haven't had any problems on my end. Okay, so let's go ahead and see what the next challenge is. So we did ping command. Oh, the next one is called piece by piece. Alright, so everybody, if you wanted to solve this challenge yourself, this is the link over here. You're going to need to have here's the link for the next challenge we're going to be doing. But in the meantime, let me go ahead and set up the next challenge. So we said we did printer shares, we did ping command, and we're doing piece by piece. Okay, let's get started. Alright everybody, this is a guided walkthrough for the Piece by Piece challenge from PicoCTF 2026 as part of their general skills set of challenges. So it says here, after logging in, you will find multiple file parts in your home directory. These parts need to be combined and extracted to reveal the flag. Additional details will be available after launching your challenge instance, so we're just going to click on Launch Instance, and we're going to see that we're given some SSH credentials to log into the server. So it says SSH to dolphincove.picoctf.net and log in as CTF player with the password, this password over here. So before we get started, what we need to do is we need to open up the workspace because we're going to be solving this with the Scilab web shell. So click on Open a Workspace, and then inside the terminal over here, we want to right click and then select this frame, then select Open Frame in New Tab. So that's going to put the web shell in its own browser tab, which is what we want. Which is what we want if it works. Okay, so afterwards we'll have access to the web shell here, and we're going to be using SSH to access this challenge. So the information we're given is this. So this is the information we're given. so let's go ahead and decipher this. Where's it? Okay, so it says here, SSH to dolphincove.picoctf.net and this port, and then log in as CTF player. So if we actually want to create the SSH command that we're going to be running, it's going to be SSH CTF-player at dolphincove.picoctf.net. So just copy this, paste it in, and then we need to provide a port number. So -P and then this port number. So just remember that your port number and my port number are not going to be the same, and the port number is different every time we start up the server. So this is the command, but this is what the command is going to look like that we're going to be using to log in. Anyways, so let's go over to the web shell, paste in the command. So SSH CTF player at dolphincove.picoctf.net -P, the port number. It's going to ask us if you want to continue connecting. The answer is yes. And then it's going to ask you for the password. So the password is given to you in the challenge description over here. So just copy it, go back to the web shell, and then paste in the password. When you paste in the password, you're not going to see any output. This is normal. Just hit enter, and then you're logged in. Okay, so before we continue, let's talk about what we need to, well, first of all, let's take a look at the instructions.txt file. So cat instructions.txt. It says here, the flag is split into multiple parts as a zip file. Use Linux commands to combine the parts into one file. The zip file is password protected. Use this super secret password to extract the zip file. After unzipping, check the extracted text file for the flag. James, hello, nice to see you here. Okay, so what's going on? So this is PicoCTF 2026 piece by piece. In this challenge, we're asked to combine a file in order to extract the flag from it. So what we're doing in this case is we're reassembling a multi-part zip file. After we've logged into the server, we see that there are instructions with the message above talking about the separated parts of the file. We need to combine them into one zip file. Okay, to put a multi-part zip file together, we can use the cat command and output the results into a new file called archive.zip in this case. So we got part AA, part AB, part AC, part AD, and part AE. We cat them all, and then we put it into one file called archive.zip. Okay, so back at the web shell, we're going to cat part AA. Actually, wait, I think I can just copy all this. So we're just going to copy all of this, then paste it. Okay, so we're going to read all of these files together and then redirect it into a file called archive.zip. And then after that, we see that there's a zip file in here. So zip archive file, okay. So to unzip the file, we just need to use the unzip command, and it's going to ask us for a password. Remember that in the instructions it said that the password for the file was super secret. So just type that in. And while you're typing it in, you're not going to see any output. That's normal. Just put in the password, hit enter. And then it says extracting flag.txt. So the last thing we need to do to finish the challenge is to just read flag.txt. We could call it HackerFrogs like and subscribe. I guess we could. Okay, so read flag.zip, sorry, flag.txt, and we got the flag over here. PicoCTF zip and split files are fun, okay? Read the file, sorry, copy the flag, then go back to the challenge, and down at the bottom, submit the flag, and you're finished. All right, everybody, that was a guided walkthrough for the piece by piece challenge from PicoCTF 2026 as part of their general skills set of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, let's go ahead and make sure that the web shell is closed here. I think we've got 2 more challenges, or maybe 1 more challenge. We got 1 more challenge, I think, and then we're finished with these challenges for the day. Let me go ahead and pull up the next challenge. Next challenge is Password Profiler. So this one's pretty fun. This one, I'm pretty sure we can't solve this one using the web shell. Yeah, we can't complete, actually maybe we can. Let me take a look at a bit of research first. So we're going to be using the CUPP script. Will you do any of the harder ones? We might do some of the harder ones later. Doing the easier ones first. So this is the script we're using right here. How many files do we need for this? So this is just cupp.py. Oh, Yeah, I'm not too sure if we can run this script just by itself. Huh. Actually, let me try running this from the web shell first, just to see if we can demonstrate it from the web shell instead of another terminal. Download the repo as a zip. I'm pretty sure we just need to the thing is that the web shell can't download anything that's not from the PicoCTF domain. We can just, like copy and we can just copy and paste the raw script itself. Yeah, we need the CFG file. Cup.cfg. So maybe getting away with just copying those 2 files is okay. Where did I put it? It's like cup.cfg over here. Configuration file, just copy the raw file. Okay, and then we'll try running the script. CUPP, no, test.py. Okay, so it seems like we can run it if we just if we just copy over 2 files. Only 6 years old, only 6 years old. Test, test, test. We'll just put in some random birthday. Must enter 8 digits. 22. Was that not 8 digits? 2, 4, 6. Okay, so it looks like if we copy over the contents of 2 files, then we can do it from the web shell. So the reason why I care about doing it from the web shell is because not everybody's got access to their own Linux virtual machine or their own Linux machine to do these challenges. So I'm trying to be inclusive to as many people as possible. Okay, so did it create the test file? Yeah, okay. And the other thing I wanted to know is if there's John the Ripper. There's no John the Ripper on here. Okay, so if there's no John the Ripper, maybe there's hashcat. There is hashcat, because we're going to need to do some password cracking for this challenge. Okay, so let me go ahead and do the intro for the challenge, and then we'll get started. Who is not running Linux as their daily driver? Well, more people than you'd expect. All right, everybody. Oh, sorry. Let me get the presentation file. So this is Password Profiler. Okay. Hey everybody, this is a guided walkthrough for the Password Profiler challenge from PicoCTF 2026 as part of their general skills set of challenges. So it says we intercepted a suspicious file from a system, but instead of the password itself, it only contains a SHA-1 hash. Using OSINT techniques, you're provided with the personal details about the target. Your task is to leverage this information to generate a custom password list and recover the original password by matching its hash. Download the following files. So it says user info with the personal details, hash, which is the SHA-1 hash of the password, and check password, which is a script to test the passwords against this hash. So what we need to do is we need to download all of these files, and then we need to start doing some cracking. So let's demonstrate. So the first thing we want to do is we want to click on Open Workspace over here, and that's going to open up the web shell terminal. We're going to be solving the challenge inside the web shell terminal. You want to right click on the terminal and then select this frame, and then select Open Frame in New Tab. From here, you're going to see that the web shell is in its own web browser tab, which is what we want, and we're going to create a directory to work inside of to do this challenge. So we're just going to call this directory Profiler, and then we're going to move into the directory. Okay, from here we're going to download the 3 files that we need to do the challenge. wget space and then the file address. So we got 3 files here. So user info, right click on it, exit the workspace, right click on it, select copy link, then the web shell, wget space, paste in the file address, hit enter to download that file. Then we need to do this 2 more times. So the hash is over here, copy that link, wget space, paste it in, download that file, and then there's 1 more. So the check password script, right click, copy link, web shell wget space, paste it in, download that file. Okay, so Saint of Ice, hello, nice to see you here, and thank you for lurking. So we've got 3 files. We've got the userinfo.txt, which has a bunch of info about this particular user. So Alice Johnson, we got a birthday, and some other names. So the other thing we have is the hash.txt file. So what we want to do is we want to take this hash and we want to crack it to try to figure out what the original password was. So what we can do is we can use a particular tool that's called CUPP. Let's talk about it. So this is PicoCTF 2026 Password Profiler. In this challenge, we're asked to build a custom word list to crack a password hash. So what we need to do is we need to build a custom word list of a bunch of different words or different passwords that are based on this user's information. So their first and last name, their nickname, their birth date. So these are the details about the user that we're given, and we can use a tool called CUPP, so common username password profiler, to create a large list of potential details, potential passwords based on these details. So the CUP tool is what we're going to be using. So CUPP, Common User Passwords Profiler. It can create a large list of passwords based on the user information passed into it. So afterwards, we can crack the hash. So we can use a custom password list. We're going to create a custom password list with the CUPP tool. So the CUPP tool can be located over here, and we'll include this link in the video description. So normally what we would do is we would clone the repository over here, but the web shell can't download. We can't clone the repository from the web shell because it doesn't have access to GitHub. So what we're going to do is we're going to copy 2 files over to our web shell, and then we can run the script. So go over to cupp.py in the list, and then click on copy raw file. So click on that button, and then we're going to go over to the web shell, and then we're going to nano cupp.py to start editing this file. We're just going to paste in all the raw content for the CUPP script that we copied, and then we're going to save it out. Control X, Y, and then enter. So we got we got the script over here, but there's another file that we need to download with it. Otherwise the script won't work. So we're going to go back to the repository, and then we're going to look at cupp.cfg. So like we did before, we're going to click on this button, copy raw file, then go over to the web shell, nano space cupp.cfg, and then we're going to paste in the file contents we copied. Okay, so Control X to save the file, Y, and then enter. Sick in the mind. Hello, nice to see you here. Well, the script has a funny name now, doesn't it? Anyways, good afternoon, Sick in the Mind. Nice to see you here. Okay, so we're gonna run the cup script in order to make the custom custom word lists. So let's take a look at the user info before we run it, so that we got a reference. So let's see, Python space cupp.py, and then we need to run it in interactive mode. So cupp.i. So one more time. So here's our user info. So cupp.py -i for interactive mode. So it's going to ask us for some information. So the first name is Alice. The surname is Johnson. The nickname is AJ. The birthday is 15071990. The partner's name is Bob. And the child's name is Charlie. Okay, so the rest of this stuff we can leave blank. So we're just gonna hit enter for all this. Do we need to, we want to add some keywords about the victim? The answer is N for no. Do you want to add special characters at the end of words? No. We want to add random numbers at the end of words? No. Leet mode? No. And do you want a hyperspeed print? This is just going to print out the output while it's running. We don't want to see this, so just type N for no. Okay, so we should have a list called alice.txt with 5,130 words. Let's check. So let's word count alice.txt. Okay, so just to make sure this has what we want, we're going to read it. Nickname is Charlie versus child's name. Oh, the nickname was not... Wait. So this is a bunch of passwords based on the information we gave to the program or to the script. Hold on. Okay, so we see a bunch of numbers based on the birthday. And then, yeah, so we put the nickname, AJ, in front of there. Okay, so the last thing we want to do is we want to submit all of these alice.txt passwords to the check password script over here. So we run checkpassword.py. And what it's looking for a file called passwords.txt. So we're just going to rename alice.txt to passwords.txt. Okay, Sick of the Mind says, was going to trying to say it's been a long day. It's typing, so typing is ready to check out for the day. No worries, no worry. Sometimes it's hard. Okay, so we're just going to rename alice.txt to passwords.txt. And then we're going to rerun the script. So python checkpassword.py. And then it says password found. And then PicoCTF AJ something something something. So before we go ahead and submit this as our answer, we're also going to take a look at how we could how we can double check this. So the way we would double check that this password is actually associated with the hash that we found over here is we could run the md5 sum command along with this. So echo out this password. And then pipe it into, sorry, not MD5 sum. I think it's like SHA-1 sum. Because they said that this was a SHA-1 password hash, right? SHA-1. SHA-1 or SHA-256. I'm pretty sure SHA-256 is SHA-1, but let me double check that. Does Linux SHA-256 output SHA-1 hash? No. Hold on. What command was I thinking of? Password profiler. Because when I was doing my SHA-1 sum. SHA-1 sum is the command we're looking for. Okay, so one more time, we'll pipe that into SHA-1 sum. So we see that these two hashes match. So the hash.txt file has this hash, and when we echo the password we found into SHA-1 sum, we see that we've got the same password hash. So with all that said and done, we can solve the challenge by copying the flag, going back to the description over here, and then pasting in the password. Submit the flag, and we're finished. Alright everybody, that was a guided walkthrough for the Password Profiler Challenge from PicoCTF 2026 as part of their general skills set of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so we're just gonna move on into the next part of today's live stream, which is the, well, even more educational stuff. So we're doing topic number 3, and topic number 4 is on deck. So topic number 3 is HackerFrogs AfterSchool Digital Forensics. So let's go ahead and get that started. I'm just going to close out all these windows that we're not using because it kind of irritates me when I've got too many tabs open in my browser. Okay, so what are we doing today? This is HackerFrogs AfterSchool Memory File Forensics Part 1. This is part of our Digital Forensics class, and we've only got this class and the next class, and we'll be finished with Digital Forensics, and we'll move on to the next topic, which is going to be cryptography, I think. Welcome to HackerFrogs AfterSchool. This workshop is the seventh class for Digital Forensics. In the last workshop, we learned about the following digital forensics concepts. We learned about Autopsy forensic software. Autopsy is the GUI implementation of the Sleuth Kit, which is a CLI program, and it allows users to view the contents of disk image files in a much more intuitive manner. In this workshop, we're going to be doing 2 challenges. We're not going to be doing... Oh, no. Okay, we are going to be doing 2 challenges. So Device Memory Forensics with Volatility and Advent of Cyber 2022, Day 11 Challenge Part 1. So let's get started. So what is memory forensics? Digital memory forensics is the examination of data in computer memory. The advantage of memory forensics. Volatile memory can contain the decrypted versions of encrypted files, passwords, and encryption keys. Volatile memory also contains data about all processes running on the system, which can include malicious processes, that is, malware. Memory forensics can also provide insight to process creation and termination times and network connections, which can help investigators track the sequence of events in an incident. So for memory forensics file creation, the software used for the creation of memory forensics files differs depending on the OS of the system to be dumped. So if you're dealing with a Linux system versus a Windows system versus a Mac OS system, the tools that are used to create these memory dumps are different. Some popular options include Lime on Linux, WinPmem for Windows, and OSXPmem for Mac OS. Okay, Kelvruhari, hello, nice to see you here. I'm dreaming to be a great teacher like you, especially on IR. Incident response? I mean, I'm not especially an incident response person, but thank you for the compliment. So the tool that we're going to be using today is called Volatility. And Volatility is a powerful free tool used for memory forensics written in Python. So what we're going to be doing is we're going to be using a TryHackMe module to learn about memory forensics. So TryHackMe runs an event every December, which covers a lot of different cybersecurity topics, including digital memory forensics. We'll be looking at a TryHackMe Advent module to learn about memory forensics. And this is going to be TryHackMe Advent of Cyber 2022, Task 16. So I've got the link for it over here. And if you want to take a look at it yourself, then that's the link. So which task is it? This is going to be task number 16. So in this room, first of all, I'm going to reset my progress on the room so you don't see the answers. And then we're going to go down to task number 16. So task 16, so it says memory forensics, not all gifts are nice. So open up this tab and then start the lab machine. So the lab machine, I'm pretty sure this is a CLI terminal. So it doesn't really affect you if you're using the if you use the attack box today already. So we just need to wait for this to load up. Oh. Let's put on this music. Okay, so while this is loading, we're just gonna learn a little bit about this software. Okay, so we're gonna be covering something called system processes while we work through this room. And what are system processes? One of the biggest advantages of memory forensics over other forensics methods is the ability to examine system process information. But what are processes? So simply put, processes are programs that are running on the system. For example, if you run a text editor program, that program becomes a process until the program is closed. So for example, if you run the Nano text editor, while the Nano text editor is running, it becomes a process on the system. So on the Windows OS, the Task Manager app lets us observe which processes are running on the system. So in the system, at any one time, you've got a bunch of different processes that are running on your system typically. Processes are divided into two categories. Processes are divided into two categories. There's user processes, which are programs started by users, and there's background processes, which are run and managed by the operating system. Okay, so we're going to be talking about volatility memory forensic software. It's a powerful free tool used for memory forensics written in Python. There are two major versions of volatility currently in use. There is Volatility 2 and Volatility 3. So what's the difference between Volatility 2 versus Volatility 3? So this workshop is going to be using Volatility 3, but keep in mind that Volatility 2 is still used regularly since there are many plugins and modules exclusive to Volatility 2. As a consequence, we need to be careful when looking up volatility commands. As a rule of thumb, all Volatility 2 commands include the profile argument, and Volatility 3 commands often include an OSType.module argument, such as windows.pslist. So we've got an example volatility command over here. Let me make this nice and big in the text editor so that you can better understand it. Okay, so this is vol2. And this is vol3. So we're just trying to illustrate how these commands are going to look different between the versions. So they're both going to use they both usually use a Python script called volatility, but in Volatility 2 we include a profile for the type of memory file that we're looking at. But in Volatility 3, we do OSType.module. So, for example, windows.pslist. Okay, so I think our system should be booted up by now. Let's check. So TryHackMe over here. Okay, that's great. All right, so we've got this Volatility 3 directory inside of here, and let's go ahead and move into it. So cd space Volatility 3, and we've got all of our files for Volatility 3 in here. Okay, so the great thing about this particular module is that they've got a bunch of information about memory forensics, about why memory forensics is useful. They talk about processes. They talk about volatility over here. So if you're interested in learning more, you can go ahead and read all the information over there. So let's see. So save time with output redirection. So the thing that you need to understand when you're running these volatility commands is that it's a good idea to output each one of your commands into a separate file so that we can look at those files later if we need to look up some information instead of rerunning the command. So for example, we would run volatility, and then we'd run some Windows module and then redirect it into a text file, so some module.txt. Okay, so what we're going to do for this particular workshop is we're going to be solving some of these TryHackMe questions. So if we get stuck, we can always look at a cheat sheet. And let's see. I'm pretty sure I just got this from Google searching. But this includes a bunch of different commands that we would do inside of volatility in version 3. Well, they've got volatility 2 and volatility 3. Here's the cheat sheet if you want to take a look. Okay, so I think there are a bunch of questions down over here. So the first thing we're going to do is we're going to move into the volatility directory, so cd volatility 3. And what we're going to do first is we're going to inspect the Windows info to answer the first question over here. So there's a bunch of questions down at the bottom of this task. So the first one is, what is the Windows version number that the memory image captured? So we want to get the Windows version number in the memory image. So we'd run this command. So the command is vol.py, or that's python vol.py, and then the rest of the command. So python 3 vol.py -f, so the file that we're working on, workstation.vmem. So this is the virtual memory file, and we're looking for windows.info. So we're just going to copy this over. If you want to run this yourself, this is the command. So let me go ahead and paste this in. Paste. Do we get to paste? Does it not want to let me copy paste? Just a second. Okay, copy this. No, it won't let me copy paste. Alright. Let me just type it out then. So python 3 vol.py -f workstation.vmem windows.info. Okay, and like we were saying before, we probably want to redirect all of this into a file. So we're just going to redirect this into windows.info.txt. So we'll run the command, and then after it's finished, we can take a look at it at our leisure. So the commands some of these commands can take quite a while to run. So you just have to be patient. So let's see, what is the Windows version number that the memory image captured? So the command we're using is windows.info, which gets some basic information about the type of Windows system that is being that is contained in the virtual memory file, the virtual memory file. Okay, so let's see. In the resulting output, note this line over here. So PE, Major Operating System version 10. So the version of Windows that is being run on this particular memory file is Windows 10. So if we go back up here, it's not finished yet. Okay. Well, I mean, we can answer Windows 10 as the answer. Okay, we'll come back to this in just a sec whenever the system is finished. So while we're waiting, we can take a look at the cheat sheet over here. So volatility is capable of doing a lot of interesting things. So for example, over here, we can take a look at process information inside of the memory file here. So process information. We can also, let's see. We can also get the commands, so a list of command history. We can get information, the networking information, such as NetScan over here. So one of the interesting things that you might be able to find is the system's IP address or other IP addresses that were being accessed by the system when the snapshot was taken. Okay, so first paste it in a notepad, then TryHackMe, and then copy it there to paste into the CLI. Paste it in a notepad first. Oh, no. The thing is that it's not going to work for this particular instance because there's no clipboard. There's no clipboard here. Okay, and what else? So NetScan, you can also take a look at the files. The files inside of the dump. All sorts of other great stuff. 73%, huh? Okay, so the next question that we're going to be answering here, what is the name of the binary/gift that Secret Santa left? So for this question, we're looking for running processes. So to look for running processes to answer this second question, we can take a look at the process list with the windows.pslist module over here. Let's go back in. This is taking a long time. But in the meantime, we gotta wait over here. But if anybody has any questions about what we're doing today, go ahead and leave them in the chat. I'll try to answer them as best we can. So the walkthrough document that we're using right now is over here. So one of the big reasons why we redirect everything into a file when we're working with volatility is because some of these scans can take a really long time. I wonder if we can make this a little bit bigger. Uh-oh. Did that reset everything? Hold on, let me see if we... No, it's a blank file. It wasn't able to... Okay, you know what? We'll just skip on. We'll just skip on over to the next thing. Anyways, all right. Let's take a little break because I need to take a little bit of water. But in the meantime, you can check out these birds. Okay, So I'll be back in about 30 seconds. I just need to take a little water break. Okay, back to the hacking. So what we're going to do is we're going to, well, we lost all the information from the first scan, so we're just going to move on to the second scan. So the second scan is, we're going to be looking for running processes to answer the second question. So this is the command over here. Let's go ahead and type in that command. So Python 3 vol.py -f workstation.vmem windows.pslist. So this is the module that we're going to run. We're just going to redirect it into a file called pslist.txt. Okay, this one runs a lot faster than the other one. That's good. Okay, is it going to come back to us and... oh man. So what we're looking for is the name of a binary that's being run as a process. Okay, I think it's done. Alright, so it looks like it didn't print out here. So let's take a look at, what do we call it? pslist.txt. Okay, so here are all the processes that are being run, and it's actually a lot of information. So what we're looking for is we're looking for an executable. I mean, looking for an executable is kind of... it's kind of, well, everything's an executable. But anyways, we actually see an interesting, a file with an interesting name over here. It's mysterygift.ex something something. So the problem here is that inside of the process list, there's a maximum length to the file names. So the exe, or the e on the end of the mysterygift.exe, it got cut off. So this is the name of the binary / gift that Secret Santa left. So mysterygift.exe. Okay, that's the correct answer. And the next thing that they're looking for is the process ID of the binary. So inside of the PS list, there are 2 numbers at the start of every process. So the first number is the process ID. So in this case, for svchost.exe, the process ID is 3500. And the next number is the number of the process that spawned this process. So this is the process ID, and the other number is the parent process ID, or PPID. I guess we can talk about this. So each process has a process ID, or PID. Each process also has a parent process ID. That's called the PPID. Okay, and so what is the process ID of this binary? So we're looking at the one down below. this interesting mystery gift.exe, and the process ID is 2040. 2040. Okay. And then we're asked to dump the contents of this binary. How many files are dumped? So to dump, when it says that we want to dump the contents of the binary, what we're really doing is we're dumping out the binary and all of the files that are associated with the binary. And we can do it with this command over here. Okay, so dump the mystery gift binary to answer the fourth question. So the first thing we're going to do is we're going to create a directory to dump the files into. So make a directory here called dump, and then in the terminal we're going to use this command over here to extract all the files associated with the mystery gift binary. So the first thing we do is make directory dump, mkdir dump, and then we run this command. So this is the command if you want to take a look. Before we run the command, we might as well take a closer look at it. Okay. So inside of the volatility program, we have to specify a directory to dump into, and we're dumping into the dump directory. We're working on workstation.vmem, which is the -f over here, and we're running this module, windows.dumpfiles. When we run this module, we need to specify the PID of the process that we want to dump out. And in this case, it's 2040. So let's go ahead and run that command. Python 3 vol.py -o dump -f workstation.vmem windows.dumpfiles -PID 2040. Okay, so it's dumping out all the files associated with the process ID 2040, which is the mystery gift file, and it's putting them all in the dump directory. So the question here is asking how many files are dumped. So I mean, I'm pretty sure we can do ls dump and then get the word count for that. So it's 16, it looks like 16 files. If we move into that thing, into that directory ourselves, oh man, it's hard to look at. It's gonna be off, is it not? Okay, let's just ls dump. So this is, it's 16 lines here. We'll try submitting 16. Yeah, this is correct. So when we run ls, it just outputs the files with one per line. Okay, so if you want to learn more about volatility, check out the dedicated room here. Oh, was that the last question? No, we've got more questions after this. Okay, so cd dump ls, we can count the number of files by piping the output of the ls command into the wc command. So ls pipe into wc, there's 16 files. So submit 16 as the answer for the fourth question. Okay, how much time do we have left? I think there's one more. I think there's one more. So Met 16 is the answer for the fourth question. I could have sworn that I had more questions. You know what we might do? We might do the second part of this workshop right now. Hold on. Oh, why is this taking so long to load up? Okay, here we go. So let's see. Memory Forensics Part 2. Did someone drop the internet again? I don't know. Okay. We've got some additional questions that we're going to be answering over here. So our additional questions, I think I put it in another workshop that I did a while back. Okay, so we've got some extra questions that we made. So question 1 is, what process created the mysterygift.exe file? So for this question, we're going to go back. Let me put this over here. So what process created the mysterygift.exe file? If we look back over here, and we take a look at the PS list. So mysterygift.exe has a process ID of 2040, but it also has a parent process ID of 5888, which means that if we look in this list for process 5888, we'll figure out which process created the mysterygift.exe file. So we can probably just cat this out and then grep for it. So grep 5888. So 5888 is command.exe. So the command.exe process created the mysterygift.exe process. So that's the answer we're looking for. Okay, so the next question after this is, according to the memory dump command line history, what suspicious file is opened by notepad.ext? Include the full file path. Okay, so the first thing we want to do is we want to take a look at the command line history inside of the memory dump. So if we go over here, so command line is one of the modules for Volatility 3. So let's see. So it's just windows.command line. So let's go back in. Uh-oh. Uh-oh. Looks like TryHackMe is having a bad time. Okay, so that was like Advent of Cyber. (2022). Let me go back and see if I can get this back. Okay, where's my list of links? Okay, so... Alright, we got it back. Okay, so once again it's Python 3 vol.py -f workstation.vmem, and then we're going to run windows.cmdline. We're going to redirect it into a file called cmdline.txt. Okay, and what this should do is it should get us a list of all the commands that were run on the system that were in memory. Okay, so we're going to look at cmdline.txt. So these are all the commands that were sent. And what we're looking for is we're looking for a suspicious file opened by notepad.exe. So we need to grep for notepad.exe, and we'll probably find what we're looking for. So read the file, then grep notepad.exe, .exe, and we find here that Notepad was opening up a file called secretfile.txt. So we are able to find that by using the command line module. Very useful stuff. Okay, so we've got a couple more questions to go. So according to the memory dump dumps networking information. What program is associated with the local port 80? What about the foreign port 80? So we're looking for networking information. So if we go over to our cheat sheet and we're looking for networking information, we can use this command over here, netscan. So windows.netscan and windows.netstat. I'm not exactly what the difference is between these two modules. We can try running them both. So we'll go back to the terminal over here. The good thing is that most of these commands are very similar to each other. So we're just running windows.netscan, and we'll just redirect that into netscan.txt. We'll do the same thing with the netstat module, just in case there's some big differences between the output of the two modules. And is it finished? I can't tell if it's making progress or not. I guess we'll just wait for it. So the networking information, what program is associated with the local port 80? What about foreign port 80? The other thing we could do is we could also run all these commands as background processes so that we still have access to the terminal while the process is running. Okay, it finished up. Okay, so there's netscan and there's also netstat. So we'll do another pass with the volatility, but using the netstat module instead. And we'll just run that as a background process. And even as a background process, it still wants to show us. Okay, let's hope this... Volatility was unable to read a requested page. No suitable swap file has been provided. An intentionally invalid page. No further results will be produced. Okay, that's fine. maybe what we're looking for is a netscan.txt. So let's take a look at it. Nothing is here. I wonder why nothing appeared. So both... Oh. So netscan.txt. Okay, so netscan did get some stuff. So we're only looking for port 80, because the question in this case is asking for which program is associated with local port 80, and what about foreign port 80? So local port 80, well, we could probably just do like we could probably grep for port 80 and see what shows up, because otherwise there's a lot of information here. Okay, so port 80 on TCP/v4 is python.exe. So python.exe is running on port 80. And there's also mysterygift.exe, which is also on... No. This is... Okay, this is local port 80, because it's, this is... The interface is 127.0.0.1. So local port 80 is mysterygift.exe, but, on the other interfaces on port 80, there's python.exe that is listening. So these are the two programs that are associated with port 80. Okay, so I think there's... Let's see. Look at the other running processes. What is the parent process of the mysterygift.exe file? Didn't we answer that already? What process created the mysterygift.exe file versus what is the parent process of the mysterygift.exe file? Okay, well, I mean, this might be talking about PPIDs. So if we take a look at pslist.txt and grep for the mystery gift, we see that the PPID of this particular process is 5888. And the last question here is, according to the Windows registry files, what is the name of the local host? So the name of the local host is probably something you want to take note of if you're doing a forensics investigation. And in this case, it's kind of... It's not very intuitive. So let's just walk through it. I think it's over here. Okay. Sorry, I've got too many... I got too many windows open. Okay, this one right here. So this is not super intuitive, but this is the command you would use to get the host name from a Windows memory dump. Okay, so what you need to do is you need to look inside of the Windows registry. So in the Windows registry, you can do something called print. You can take a look at the print keys. And we're looking for control set 1. And we're looking for computer name instead of control set 1. Let me go ahead and run the command. We'll take a look at the output. Okay, so vol.py workstation.vmem windows.registry.printkey -- key control set 001, control computer name, computer name. I hope I didn't make any spelling mistakes there. Okay. So there's a lot of interesting stuff you can get from memory dumps by using the right tools. Okay, so what do we got? So control set 1, control computer name is this one over here, desktop something something something. So this is a pretty common pattern for default names of computers for Windows hosts. So this is the answer here. Okay, so the next question is, obtain the file hash for mysterygift.exe, for the mysterygift.exe file, and search for it on virustotal.com to answer the following questions. So this is another thing that we could potentially do with our memory forensics. We can dump out any malicious, any suspicious looking files and see if they're associated with malware. So the first thing we need to do is we need to go back in and we need to get the file hash for the malicious file. So dump. So mysterygift.exe.img. This is the file we're looking at here. Can I copy this? Okay, I think we can copy it. And then we run, let's see, MD5 sum. Okay, so if we run MD5 sum on a particular file, we can get the MD5 hash of the file, which can be used for identification. So in this case, it is this over here. And what we can do for certain websites like VirusTotal is we can grab these file hashes and we can search for them. So let's go ahead and do that. Virustotal.com. It's a website which can give you information about all sorts of malicious software. And we can do a search. So search by URL, IP address, domain, or file hash. So this is the file hash, search for it. And did we find anything? Okay, so it says, so up here, it tells us some information about this malware. Okay, so 41 out of 71. So 41 out of 71 security vendors flagged this file as malicious. So it's mysterygift.exe, we've got a size, last analysis date 1 year ago. Okay, so we're going to try to answer a bunch of questions about this particular piece of malware based on what we find on VirusTotal. So the first question is, how many security vendors flagged this file as malicious? So here we see 41 vendors have flagged this as malicious, and the names of all of the security vendors are over here. So there's Alibaba, Arctic Wolf, AVG, a bunch of different antivirus software companies. And the next question is, according to the file's history, what is the file's creation time? So file history, creation time, we can go back in here. And I'm pretty sure we can find this in these different tabs. So in VirusTotal, there are a bunch of different tabs. Detection, detail, relations, behavior, and community. So for details, we've got stuff like the file hashes over here. And the creation time was back in 2022, November 4th, it looks like it is. Okay, so that would be the answer for the question. And the next question is, what domain name is associated with this file. So domain name associated with the file. Virus total here. Let's see if we can find any domain names in here. We'll go over to relations. Okay, contacted domains. So apparently this malware tries to contact Microsoft.com and res.public.1cdn static.microsoft.com, I'm assuming, and a bunch of other IP addresses that are associated with the with this malware as well. Henki, hello, nice to see you here. What is up? We're currently taking a look at what was it? Memory dumps and malware and memory dumps. Fun stuff. Okay, what IP addresses are contacted by this file? So I'm assuming these are it over here. So which of these IP addresses, if any, are found in the memory dump networking information? So what we could do is we could go back into, why is this terminating? So we could go back into the room and we could take a look at the networking information to see if any of these IP addresses are referenced in the networking information. In like netscan.txt. Spoiler alert, there aren't any, but it's a good thing to think about anyways. Okay, aside from mysterygift.exe, what are the other two names of this file? So, lots of malware goes by different names, and in this case, the names of the file are either mysterygift.exe or this file hash over here, .sample, or the file name that we're looking at in our dump over here. So mysterygift.exe.img. Okay, is this a signed file? So I mean, this is kind of a trick question because signed files are files that are trusted, and most malware, they're not going to be signed files. And if there is a piece of malware that is a signed file, that's a really big problem. Okay, and the other thing that's interesting here is there's a GitHub repo that is associated with this file as well. So if we look over at virus total, then go up and then go over to community. I think they identified which GitHub repository is associated with this particular malware. So https GitHub, well, this thing right here, we'll copy it, and then we'll take a look at the GitHub. Okay, so what is this? So it's called NIM-C2. So it says NIM-C2 is a very lightweight C2 written fully in NIM. It uses range from user support to employee monitoring. So what this is supposed to be is it's supposed to be a C2 implant. So a C2 implant means a way of remotely interacting with the server. And apparently this is the type of malware that it is. SysOS says NIM, it's been a while since I heard about that language. I have no idea what NIM is. And the last question is, what is the name of the GitHub project? So the GitHub project in this case is called NIM-C2. So it's been a very interesting chain of events that got us here. So we went from taking a look at the memory dump to dumping out the suspicious looking file, and then finding out more about it on virus total. So I think we might have one or two more modules on like TryHackMe that deal with volatility. Let me see if I can find them. So just in case anybody else was volatility. Just in case anybody else is interested in doing more investigation on how to learn about volatility, the tool. Oh, it does not. TryHackMe does not want to be cooperative today. NIM's good for making malware? I mean, I have no idea. Okay, let's see if we can search for volatility in here. The other thing about memory forensics is that it's not something that's super common, although it is very interesting. I think, at least. Volatility Essentials, how to perform memory forensics with volatility. So there's another module over here if you want to learn more about it. But I think that's all we have for today, so let's go ahead and wrap up this workshop. What is it? Oh, I went to the wrong place. Here we go. I think we're at like page 27. Okay, so let's review the digital forensic concepts we learned in this workshop. Memory forensics. So digital memory forensics is the examination of data in computer memory. It can give forensics investigators a view into processes running on the system. We also learned about volatility memory forensic software. Volatility is a powerful free tool used for memory forensics, written in Python. There are two versions currently used, Volatility 2 and Volatility 3. So the difference between Volatility 2 and Volatility 3, the major difference is that they're written using Python 2 versus Python 3. That means that Volatility 2 has been obsolete for over a decade, but people still use Volatility 2 because there's some modules that they didn't port over to Volatility 3. So what's next? So I think we're finished with digital forensics for right now, and let me see if I can get the outro for this. Okay, so the digital forensics lessons are done, but the next HackerFrogs AfterSchool workshop, excuse me, got a cough. But the next HackerFrogs AfterSchool workshop will start on a new course, cryptography. So cryptography is not my strongest suit, but I'll try to introduce cryptography at a beginner level so that people can start getting into it. Okay, so let's go ahead and finish off today's HackerFrogs AfterSchool. We're going to work on the last topic of the day. So the last topic of the day, what we're going to be looking at is we're going to be looking at the world of operational technology. Operational technology in ICS. So this is a module from TryHackMe. Python 2 was sunset on January 2020. Was it really that recent? I thought that Python 2 was they got rid of it like a really long time ago. Okay, I've got way too many tabs open. This is really bothering me. Okay, I think we can also terminate this machine. Okay, so what we're doing is we're learning about the world of OT/ICS. We're just going to join the room, and anybody who's interested in taking a look, I left the link in the chat. This is a free room, which means that anybody with an account over at TryHackMe can check it out. Okay, let's read all about it. So Task 1, Introduction to OT/ICS Cybersecurity. Welcome to the world of securing operational technology, OT, and industrial control systems, ICS, against cyber attacks. Most people are familiar with information technology systems, which they interact with daily. Laptops and workstations for completing spreadsheets, writing documents, and playing games. Servers that store files and provide services that businesses need to operate. Websites we visit to do our jobs, learn, buy something, or waste time. And smartphones that we can do all these things from and so much more. And yet many are unaware of the hidden world of operational technology, OT, and industrial control systems, ICS, that provides the critical services that we rely on in our daily lives. How does cybersecurity work in a power plant to prevent an attack from causing a blackout? Do power plants even have computers? Surely they must, right? But if they do, how are those computers used to generate electricity? And how do we protect critical infrastructures such as power plants from cyber attacks? Learning objectives. In this first room, this is a first room, you will learn the differences between IT and OT/ICS. Be able to explain the differences, be able to explain the basics of how an OT environment works. Understand the main OT systems that are found in critical infrastructure, such as power plants, water treatment facilities, and manufacturing plants. It's called isolation, but how well do people practice isolation? See the human role operators play in these types of specialized environments. Comprehend the basics of how cybersecurity is essential to safe, reliable operations in critical infrastructure. Okay. So, no prerequisites, great. Let's get started. Okay, Task 2. What is OT/ICS? Operational technology. Operational technology, OT, is the use of computers to monitor and control physical equipment and processes in the real world. Such processes could include a generator inside a power plant that spins to create electricity, a conveyor belt that moves parts within a manufacturing plant, computers that operate medical equipment such as MRI or CT scanners, safety systems to prevent a train from overturning when taking a curve too fast, building management systems that control elevators, badged door access, HVAC and lighting, embedded computers in car control systems such as engine control, anti-lock braking systems, ABS, and electronic stability control, ESC. Okay, so industrial control systems, ICS, are a specific type of OT system found in industrial environments. So such environments include power plants, oil refineries, steel mills, food packaging facilities, pharmaceutical manufacturing, and water treatment plants. So ICS, so it's a type of operational technology system, okay? So environments such as hospitals and cars are not considered industrial environments. Systems that are used in these environments to monitor and manage physical equipment and processes are only considered OT, not ICS. So they're operational technology, not industrial control systems. Though you'll find people often use the term interchangeably. Okay, and then we got SCADA. Supervisory Control and Data Acquisition, SCADA, or SCADA. SCADA and SCADA. I think I've encountered some people who get mad if you pronounce it either SCADA or SCADA. I'm not too sure which one. So this is a type of ICS used over a wide area network to monitor and control remote equipment and processes. Examples of wide area network connections include 5G cellular connections, microwave radio links, and satellite connections. SCADA, I think it's supposed to be SCADA, is used to monitor and control equipment in remote environments that it can only be reached with WAN technology such as electronic substations, offshore oil rigs. If they get mad, tell them to make a GIF about it, of course. So WAN technology such as electronic substations, offshore oil rigs, pipeline pumping stations, offshore wind farms, remote solar farms, etc., etc. Other terms you might hear that refer to specific types of OT include cyber physical systems, CPS, industrial automation and control systems, IACS, and automation and control systems, or ACS. So in this room, the term IoT is used to represent all of these other terms, including ICS and SCADA. I pronounce graphics with the J too. Graphics? Anyways. Okay, so what does the O in OT stand for? So this is operational. And what does the C in ICS stand for? So industrial control systems. Okay, next task. So how does OT/ICS work? What does OT do? OT, operational technology, monitors and controls physical processes and equipment in the real world. For example, if I have a power plant and the plant itself uses ICS to monitor and control the processes of generating electricity. If I have a power plant, the plant itself uses ICS to monitor and control the process of generating electricity. At a water treatment facility, ICS would be used to monitor and control the process of making water safe to drink and delivering it to customers. Okay, so we also have programmable logic controllers, or PLCs. So OT systems such as the programmable logic controller, the most common type of OT asset deployed today, have both inputs and outputs. Okay, so we've got a PLC over here. So the inputs would be the temperature sensor or the level sensor, and the output would be to the motor or the pump. So I'm guessing depending on the temperature sensor, well, the inputs of the temperature sensor and the level sensor, it would affect the operations of the motors and pumps for this PLC. Okay, think of a PLC as a thermostat for an air conditioner you might have in your home or office. This thermostat has a sensor that continually reads the temperature to determine the room temperature. A PLC is programmed with logic so that if the room temperature exceeds the desired temperature, also referred to as the set point, it will send a signal to turn on the air conditioning unit. Okay, so let's think about this for a second. So we got our PLC. PLC, in this case, it's going to be a air conditioning controller. So if the PLC input from the thermometer, is it? Temperature sensor. Temperature sensor indicates that the temp is higher than the set point. So in this case, the set point is the desired temperature. J-Bad, hello, nice to see you here. I work in OT security. I've heard a lot of, what are they called? Horror stories about OT security and how it's really hard to do OT security. But let me know what your experience is, J-Bad. Okay, let's put 90 minutes on the clock, because I forgot to set up my time. So if the PLC input from the temperature sensor indicates that the temperature is higher than the set point, then the PLC activates the AC device to lower the temperature. Okay, and the motor and the pump, great. Inputs. Inputs are pathways that bring data into the PLC from sources such as sensors that monitor conditions in a particular environment. Common types of sensors include, but are not limited to, sensors that measure the temperature inside a furnace, sensors that measure how full an oil storage tank is, sensors that detect if a dangerous overpressure situation is occurring, and sensors that detect changes in vibration patterns to identify physically failing equipment that needs to be replaced. So that's inputs. So as for outputs, these are the pathways that allow the system to send signals to physical systems in the real world, such as pumps, valves, and motors. In our example of our air conditioning unit, once the thermostat determines that the room has reached the desired temperature, it sends a signal via an output to turn off the air conditioning unit. Okay, and then we will discuss PLCs and other OT ICS assets in greater detail in later rooms. Great. Okay, so we've got our questions. When a PLC needs to send a signal to turn off a motor in the real world, it sends a signal through what type of connection? So this is the output connection. Okay, and let's see. What source provides the environmental data that inputs feed into the PLC? So the environmental data is obtained from sensors. Okay, great. What is OT/ICS cybersecurity? Okay, that's a good question. Where does cyber risk come from in OT/ICS? Modern OT/ICS environments leverage traditional IT technologies such as Ethernet, TCP/IP, cloud-based services, and Gen AI to improve performance and efficiency in plants and factories. While these technologies bring significant business advantages to the environment, each also introduces vulnerabilities that attackers and other types of cybersecurity risks could exploit. IT versus OT infrastructure comparison. It's also important to keep in mind how IT and OT assets in other infrastructure are different. So let's see. So the primary focus of IT infrastructure is managing data and information, but the primary focus of OT infrastructure is managing physical processes and machinery. Okay? So the top priority of IT is confidentiality. The top priority of OT is safety. So the asset lifespan of IT is 3 to 5 years. Hardware is often replaced, but the lifespan of OT is long, 10 to 30 plus years. Legacy systems are very common. So I mean, I guess that when you enter like an OT environment, you're very likely to see very, very old pieces of equipment that have been in use for a really long time. Okay, for patching, in IT, regular scheduled updates are standard, but patching in OT is difficult or rare. It requires expensive downtime. Okay, I'm starting to see the problems that might occur. Response to failure. Rebooting is acceptable, but for rebooting is acceptable in IT, Windows 95, maybe. But response to failure in OT is rebooting can cause safety issues or physical damage. So OT assets such as PLCs are now assigned IP addresses to connect to the OT network and communicate with other systems. For example, a human-machine interface, or HMI, is a graphical interface used by human operators to monitor a physical process, which is in turn controlled by a PLC. Okay, April says, ski free, hello, nice to see you here, and, not maybe, in current use. Oh, yeah. Yeah, I mean, I'm sure that, there's a lot of old equipment that's being run on legacy operating systems. Okay, so the human operator uses the HMI not only to visually monitor how the process is operating, but also to make adjustments, such as in response to an alert. So what type of damage could an attacker do if they gained access to a power plant and accessed an HMI? So if we got some hacker who hacks into the HMI, which is attached to the PLC, that is power plant. I mean, I guess they could stop the power plant, or they could overload the power plant. Could they stop power generation to create a blackout? Could they poison water in a water treatment facility? Could they cause systems to physically break down? Ski Free was an old game that came with the Windows 3.1 and 95. Oh, okay. Could they prevent food from being packaged safely and sent to stores? All of these types of scenarios can happen, and many others. And in fact, the situations listed above are just a small list of the types of OT ICS cybersecurity incidents that have already happened. Okay, cybersecurity is a necessity in OT ICS. So this cybersecurity is necessary to ensure the safety and availability of OT ICS environments. As the number of cyber attacks targeting OT ICS networks and connected IT networks has nearly doubled each year since the Colonial Pipeline incident in 2021, defenders of these specialized environments are woefully underprepared to defend OT against attackers, but it is possible, and it doesn't have to be hard. What type of system is used by a human operator to interact with a PLC and control a physical process in the real world? So this is a human-machine interface. Okay, data centers use OT as well. What does what does OT control in the data system, in the data center? I mean, I could guess that it's that they're operating like power generation or something? Monitoring, okay. So which 2021 incident marked a turning point for OT ICS security, after which annual cyber attacks against these networks doubled? So they're talking about the Colonial Pipeline? HVAC, oh, okay. Power, HVAC. So I mean, I think I remember like a specific cyber attack. So US cyber attack on water treatment plant. So there was something, Florida water attack. I think this was it, yeah. So America's largest water utility hacked as US infrastructure something. So this was 2024? I thought it was older than that. Let's take a quick look at this article. Okay, American. This is. You know what? Let me ask the AI if it can give me a summary, because it's going to be really awkward looking at that website. Okay, give me a summary of the 2024 water treatment plant cyber attack in Florida in the United States. Oh no? Oh, okay. Water treatment plant that happened in 2021. Okay, I was thinking of the wrong date. Okay, so this was a water treatment plant in Florida. So this was TeamViewer. So TeamViewer remote access software exploited. Attacker gained access through the employee computer. Vulnerabilities: Windows 7 OS. Windows 7 OS shared passwords across SCADA systems. No firewall between internet and control systems. Full privileged TeamViewer account. So TeamViewer is kind of like is TeamViewer like a remote desktop? What happened? Hacker raised sodium hydroxide lye levels from 100 parts per million to 11,000 parts per million. Okay, during 3 to 5 minutes of unauthorized access. I don't know if this actually happened. I did hear that the hacker tried to increase the volume of some chemicals in the water, but I'm pretty sure that they weren't successful. Okay, plant operator noticed the change in real time and immediately reverted the settings. Public was never in danger. Okay, let's see. No arrest made. Domestic, international, unknown. So they don't know who hacked in. They weren't able to find the person responsible, apparently. And they removed the remote access. Added security safeguards into this thing. Okay, sure. Alright. Let's go back. So the differences between OT and IT cybersecurity. So IT and OT cybersecurity have more in common than they don't. Many OT cybersecurity professionals might tell you that OT and IT cybersecurity has nothing in common. That's the farthest thing from the truth. OT and IT cybersecurity actually has more in common than they don't. What is critical is to understand where OT and IT cybersecurity are different and how they are different. Because if you're not aware of those differences, you could get someone hurt or killed, let alone take down a plant in the middle of operations. So IT cybersecurity, the primary requirements are formed by the CIA triad. April says, I used to install fire alarms. I never really looked into, but I expected there could have been some ways to hack in. If not with software, then certainly if you have got access to the faceplate. Oh, I mean, that makes sense. If you've got physical access to a device, then there's a lot of bad stuff you could do. Okay, so the CIA triad is something we talk about in cybersecurity. It is confidentiality, integrity, and availability. So confidentiality is basically if the information that you're sending is secret. Integrity means that the information that you're sending is unmodified. And availability means that the information that that you always have access to the information. So for OT cybersecurity, many say that the requirements are reversed, so that we now have an AIC triad. Unfortunately, this formula leaves out the most important requirements in OT cybersecurity: physical safety. We must ensure that not only do on-site employees go home safe at the end of the day without getting hurt or killed, but that the general public and the environment surrounding the plant are not harmed as well. Every action we take to defend OT ICS networks from cyber attacks focuses first on ensuring physical safety, then on operational availability of the site, and then integrity of its data, and then finally confidentiality. In many OT ICS environments focused solely on safety and operational availability, the OT ICS networks often lack encryption. Sisoa says, with OT, safety should be redundant, and safety should never rely on just electronics. So availability is the most important thing, and then integrity and confidentiality are not really paid as much attention to. So how IT and OT cybersecurity compare? The following table compares some of the most significant differences between IT and OT cybersecurity. So let's see. For patch management in an IT environment, this is automatic and frequent, but in an OT environment, they're planned and rare. Okay, so patch management is more difficult in OT environments versus IT environments. Vulnerability scanning is very active in IT environments, whereas it is passive monitoring in OT environments. Okay, so active scanning with tools like Nmap and Nessus can cause OT assets to crash because they're not, I'm guessing because they're not designed to handle large amounts of traffic. Integrity, some. Confidentiality, not at all, because it's treated as public data. So incident response. So for IT environments, we can isolate and reboot. If a system is compromised, we can wipe it and reinstall. But for OT environments, we need to keep it running. OT systems cannot simply be isolated or rebooted without introducing safety and operational availability issues. And as far as network encryption is involved, in IT, almost everything is encrypted. But in OT, it's very low amounts of network encryption. Most OT ICS protocols do not support encryption. While newer protocols do, most plans continue to favor older unencrypted ones. Alright. What is the most important requirement for OT ICS cybersecurity? So, was it availability? Safety. Okay. And what do many OT environments not leverage? So I think we're talking about encryption here. Okay, and we can finally start talking about, we can finally get like an example here. What a human operator sees in OT environments. Okay, so bringing it all together. In this task, you will access the human-machine interface, HMI, for a specific type of OT ICS environment. You will use the interface and information presented to think and respond as a human operator would in the environment. Open the static site by clicking on the View Site button in the upper right corner and proceed to solve the questions below. Okay, so what is this? So water treatment? So we got a water tank. We have a water tank that is 65% full. So Telemon Water District. So I'm guessing this is either water storage or water treatment. And we got a reset button up here. Pump P101 inlet and valve V202 outlet. So we can start the pump, we can stop the pump, we can open the valve, or we can close the valve. So I'm guessing the pump is going to increase the water, and the valve is going to release the water. We've got an emergency stop button. Okay, so what do they want us to do? Based on a review of the HMI, what type of environment is this? So this is a industrial control system, or ICS environment. Okay. And then when you first look at the HMI, what is the current percentage level indicated by the tank sensor? So we've got 65%. Okay, and then click on the start button to turn on the pump to bring in more water into the tank. At what percentage level do you first receive an alert in the yellow warning banner? At what percentage level? Okay, so we'll start the pump. So this increases, and I'm looking for a warning banner, 85%. So we'll stop. Tank 85% full, so that's the answer. So let me just see if we can open the valve. So yeah, we can open the valve and we can decrease the water level. And I wonder when they'll give us a warning message for this, if at any time. So probably after it gets down below this level over here. Huh. So they don't care if the tank is empty. They only care if the tank is overfilled. So we'll close this, and we'll start this up. Okay, so the answer for this was 85%. Continue to allow water to flow into the tank. At what percentage does the control system realize there is danger and shuts off the pump, bringing water into the tank? Okay, so it looks like there's some sort of failsafe in this particular system that stops the pump at a certain percentage. So it's probably going to be 90% or 95%. Okay, critical 95% capacity, pump interlocked, engaged. Okay, so let's see. Redundancy, not failsafe. There is no failure yet. Yeah, the system hasn't failed. So it's looking for 95% here. Okay, so with the pump stopped, click open on the valve on the outtake pipe. What happens to the water level in the tank? The water level decreases, lowers. Okay, and I guess we're done with this. It disappears, the water level disappears. That's probably not it. Okay, let's close this up, and let's move on to the conclusion. Okay, conclusion. Nice job getting started on learning how to protect OT and ICS environments from cyber attacks. In this room, you learned about the differences between IT and OT, how ICS and SCADA systems are part of OT, how OT cybersecurity can be similar but different from IT, and the important role that human operators play in OT environments. Okay, and nice job completing this room. Check. And we're finished. Okay, so I think we might do another room from TryHackMe, since there's actually a lot of good rooms that have been published recently from TryHackMe. Although sometimes the site is not super responsive. Okay, what we're gonna do is we're gonna look for another module to do over here. But before we do that, I need to go and use the washroom. So what you can do is you can watch the birds, and I'm just going to take a little break. And we'll be back in about 2 or 3 minutes. So let's see, let's put on some birds. How about... we put on these birds? Okay, we'll be back in about 2 minutes, but enjoy the birds and the music. Okay, we're back. So, April in chat is asking about bird names. So this bird is well, these birds are Steller's jays. They're a bird particular to North America. And I guess if you wanted to read about them, there's a Wikipedia article that's pretty good. Hold on, let me see if I can get that. Okay, these guys right here. If you want to read more about them, here's the Wikipedia article. But in the meantime, let's go ahead and take a look at TryHackMe over here. So, why the red raffle? I mean, I don't even know how I earned this ticket over here. Okay, let's search for some rooms. And we're looking for free rooms. Content discovery, DevSecOps, retesting, guided pen test web, Python core ops, core concepts, Metasploit the basics. I also named that one Roger. Oh, it's Roger. Okay. The Peanut Bandit is Roger. So Linux wireless security. You know what? This might be fun. I don't know very much about wireless security. So let's go ahead and do this one as well. Modbus. Modbus? Oh, we've I recently updated my education resources over here. To include more stuff on OT and ICS stuff. So we've got all of the previous like ICS rooms from TryHackMe that we've done before. But anyways, let's try out this room. So wireless security, learn how wireless technologies work, the risks they introduce and how to defend against them. Okay, so let's join the room. So I mean, everybody interacts with Wi-Fi on a pretty regular basis, but I mean, I haven't done a lot of study on this. Let's learn this together. And we've got an hour on the clock right now. I think that's fine. Okay, so wireless frequency spectrum, where Wi-Fi, Bluetooth, NFC, and RFID sit on the radio frequency spectrum. So these are all radio technologies. So RFID is in the low frequency range. Actually, let's just for fun, we'll keep track of these technologies, and we'll just write a couple of notes. So wireless technologies, we're taking a look at 4 of them right now. So RFID, NFC, RFID, NFC. What's this third one? Bluetooth. And Wi-Fi. So let's see. So the lower the frequency is, well, it looks like the relationship between lower frequencies and higher frequencies is lower, like shorter range versus longer range. So RFID and NFC is something that you see. Well, NFC is, I think this powers like wireless contactless payments, like with your credit cards and stuff. Bandwidth, not range. Bandwidth, not range. So the bandwidth, I guess, the frequency is lower here and then higher here. Range equals power used. Okay. So far RFID is asset tracking and access control. NFC is near field communication for contactless payments and data transfer. Bluetooth is short-range data pairing and data exchange, shares band with Wi-Fi. And then we got Wi-Fi in the 2.4 gigahertz to 5 gigahertz range. Okay, and Strog, hello, nice to see you here. What inspires you to keep going in cybersecurity? I mean, if you are not educated in cybersecurity and how your technology works, you will always feel, I mean, I felt like, you know, like kind of clueless. But you'll have confidence if you understand how the machines work and how you can keep yourself safe. Okay, so it also says Wi-Fi and Bluetooth and Wi-Fi share the same frequency band, which can cause interference between devices. So Bluetooth and Wi-Fi can interfere with each other, but NFC and RFID do not, I guess, is what they're trying to say. Okay, so wireless. Okay, let's make this bigger. Wireless technologies have played a key role in enabling connectivity between devices, which has allowed data exchange in modern environments without physical connections. However, it is important to understand that these technologies may introduce security weaknesses that attackers can exploit to compromise sensitive data. Understanding how wireless technologies operate and how they could expose an organization to attacks will help build a strong foundation needed to access wireless networks. Okay, so let's see. By the end of this room, you'll be able to... So interference is a difficult subject to fully grasp. The simple explanation is the one you just did. So by the end of this room, you should be able to understand the fundamentals of wireless networking, including how devices communicate over radio frequencies. Identify common wireless technologies, Wi-Fi, Bluetooth, NFC, and RFID, and their use cases. Recognize common security risks and attack vectors associated with the wireless technologies, and apply basic security measures to protect wireless networks from common threats. Okay, so we should understand some basics about networking before we continue. Great. Okay, so Wi-Fi network fundamentals. Typical Wi-Fi network topology. So we got the internet, which then feeds into our router / access point. And then from the router, the information is passed on to our devices. So our devices are our laptop device, our mobile phone, our IoT devices, and our attackers who are monitoring. Okay, sure. Okay, nowadays people have adapted to using Wi-Fi to connect to the internet. Our attacker device, of course. It can be found in homes, offices, coffee shops, and airports. It lets devices communicate using radio signals instead of physical cables, which makes connectivity flexible and convenient. But to secure it, you must first understand how it works. The following key components make up a Wi-Fi network. There's the access point, or AP. This is the device that is broadcasting the Wi-Fi signal. Think of it as the bridge between your wireless devices and the wired network behind it. A home router is one example of an AP. So you got your access point and your clients. So these are the devices connecting to an AP, connecting to an AP to access internal resources, or the internet, such as mobile phones, laptops, tablets, printers, and smart devices. Each device has a wireless network interface card, a NIC, that handles sending and receiving radio signals. So identifiers in Wi-Fi networks. Every Wi-Fi network needs a way to be identified. Below are two commonly used identifiers. So we got SSIDs, service set identifiers. So these are simply the network name that you see when you open up your Wi-Fi settings and browse for available networks. For example, Office Wi-Fi. So we've also got our BSSID, Basic Service Set Identifier. The unique identifier of an access point, which is usually usually represented by a MAC address, the MAC address of the wireless interface. So a MAC address being a hexadecimal set of digits over here. So how wireless devices communicate? Wireless devices communicate wirelessly by transmitting radio waves over a shared airspace. Communication between devices occurs within specific frequency bands. The frequency band a device uses determines a lot about its speed, range, and reliability. There are two common frequency bands in Wi-Fi, and each comes with trade-offs. So 2.4 gigahertz gives you better range, up to around 45 meters indoors, and can push through walls and floors more easily. The downside, it's crowded. Microwaves, Bluetooth devices, baby monitors, and your neighbor's Wi-Fi are all competing on this band. Additionally, speeds top out around 600 megabits per second. Okay, Serpentor says, I've played around with AirMon and AirCrack commands before for WPA2. Yeah, I mean, I wonder how commonly you still see WPA2, because it seems like it's something that they would have phased out. I mean, I guess if people are using like really old equipment, like really old like Wi-Fi routers, then you'll still see WPA2. But like the stuff that they sell these days, they don't use that that protocol. In consumer devices, pretty common. Really? That's unfortunate. Okay, so 5 gigahertz is faster, up to around 1300 megabits per second, and is far less congested. Oh, yeah, no, I was thinking about WEP. WEP, yeah. Wireless Encryption Protocol. WPA3 is the latest and greatest. Okay. So 5 gigahertz is faster and less congested, but the signal doesn't travel as far and struggles more with physical obstacles, around 15 meters indoors. If you've ever noticed your connection drop when you walk into another room, you might be on 5G. The 5 gigahertz band, rather. Not 5G, it's a different thing. Okay, Serpentor says Cisco Meraki still sets WPA2 as the default. You have to manually set it to WPA3. Okay. So the image below illustrates a side-by-side comparison of the differences between 2.4 gigahertz and 5 gigahertz in terms of range, speed, penetration through physical obstacles, and congestion. So we've got, what do we have? So 2.4 is longer range and better penetration through walls, floors, and obstacles. It has only 3 non-overlapping channels, which is channel 1, 6, and 11. More prone to interference from Bluetooth, microwaves, and other Wi-Fi. Lower maximum throughput, and better for IoT devices and distant connections. Okay, versus 5 gigahertz, which is the higher frequency band. Shorter range and weaker penetration, 23 non-overlapping channels, significantly reducing congestion. Less interference from other devices due to a less crowded spectrum, higher maximum throughput and speed, ideal for high bandwidth streaming, gaming, and video calls. Yeah, not 5th generation, but 5 gigahertz. Okay, association process. When a device joins a Wi-Fi network, the connection process involves multiple steps, including association. The general flow looks like this. 1. The device scans the area for available networks. 2. You pick a network to join. 3. The device and AP access point exchange authentication details and establish connection. 4. Encryption keys get negotiated so traffic can be protected. And 5. Data starts flowing. One thing worth knowing is that the order of these steps can vary depending on the security protocol in use. With open system authentication, the AP doesn't actually verify any credentials during the authentication step. It's essentially a handshake that says, yes, you can talk to me. This happens in both WPA2 Personal and WPA2 Enterprise. The difference is what comes next. In WPA2 Personal, the device goes through a four-way handshake to prove it knows the pre-shared key. In WPA2 Enterprise, with 802.1x, the device associates first and then gets handed off to a dedicated authentication server, for example Radius, for full credential-based authentication. Either way, both steps have to be completed before any real data gets exchanged. Okay, so you've got your client device and your access point. Scan the device. The device scans for available networks. The device selects an SSID and sends association request. Authentication, identify verification between client and AP. Exchange keys for encryption, and then transmit secure data transmission. Okay, so SysOS says the shorter range is not due to the higher gigahertz, but the specific gigahertz and how it interacts with air. 5 gigahertz travels less far in the atmosphere and walls. Oh, okay. Okay, so factors that affect Wi-Fi signals and coverage. The strength and reliability of signals in the Wi-Fi network are influenced by several factors. Below are some of the factors that degrade the quality of a Wi-Fi connection. Physical barriers. Walls, floors, and ceilings weaken the Wi-Fi signal. Concrete and metal are the worst offenders. Even a fish tank full of water can noticeably impact signal strength. Distance. The further you are from the AP, the weaker and less reliable your connection gets. Interference. Electronic devices on similar frequencies can disrupt signals. This includes microwave ovens, Bluetooth devices, and other Wi-Fi networks. Channel congestion. Multiple networks that operate on overlapping channels could cause performance issues due to signal congestion and competition. In dense environments like apartment blocks, this can seriously hurt performance. Signal leakage. Signals could extend beyond intended physical boundaries and reach areas such as streets, parking lots, and adjacent offices, which increases exposure if not properly managed. Okay, what is the process that occurs when a device connects to a wireless network? What is the process that occurs when a device connects to the wireless network? Okay, let's look back up. Connect. So the association process is what we're looking for, right? Okay, and what occurs when multiple devices communicate on the same frequency, affecting the wireless signal and coverage? So this is degradation. No, they're not looking for degradation. Interference. Maybe that's not how you spell the word interference. Okay. It's spelled like this. Okay, task 3, Wi-Fi security. Okay. So Wi-Fi is a wireless technology that is used in homes, offices, and public spaces. It follows the IEEE 802.11 standards, which defines how wireless devices connect and communicate with each other. There are different generations of Wi-Fi that were introduced under the IEEE 802.11 standards over the years. These standards are outlined in the table below. Okay, so we've got 802.11, 802.11b, 802.11g, 802.11n, 802.11ac, AX, and BE. So they increasingly get more... Well, I mean, I guess that the speed with which the data moves goes up faster. Okay, first Wi-Fi standard, 2 megabits per second, not widely adopted, so this is the first one in 1997. Then we got 11B, which was 11 megabits per second. Then we get 11G, which was 54 megabits per second. Then we've got 11N, which is 600 megabits per second. So this is the introduction of 5G, 5 gigahertz signals versus 2.4. So let's see, Serpenter says Silicon machines and higher-end PCs Wi-Fi cards can hit the full 5 gigahertz in Wi-Fi. Okay, and then we got 11 AC, which is 5 gigahertz only. Faster speeds, up to 6.9 gigabits per second. Gigabits per second. I mean, And then we've got 11AX, which is known as Wi-Fi 6. So high efficiency, up to 9.6 gigabits per second, designed for dense environments. Okay, and then we've got very recent stuff over here, Wi-Fi 7. So this is 11BE, which extremely high throughput, EHT, multi-link operation, 320 megahertz. 320 megahertz. I mean, what's the throughput though? They talked about like 9.6 gigabits per second here, but what about this one? And what is this 6 gigahertz? Most enterprises deploy Wi-Fi 5 and Wi-Fi 6 standards because they work well with modern laptops, smartphones, and access points, which is why they're often seen during security assessments. There's a new range. Authentication and encryption in Wi-Fi. Secure Wi-Fi communication relies on 2 key components: authentication, which controls who can connect, and encryption, which protects the data being transmitted. Wi-Fi networks use security protocols to ensure that only authorized devices can connect and that data remains protected. Some common Wi-Fi security protocols include the following. Okay, so the security protocols are these ones over here. Okay, Write Me, hello, nice to see you here. And Serpenter says I had to set up a Cisco Meraki network and had to run 5 Cat7A Ethernet cable connections to get the full speeds from the APs. And what kind of speeds were you getting on that network? Okay, so WEP is broken, so it's a deprecated standard, I guess, or deprecated protocol. So WEP is a early security protocol now considered insecure. Its weaknesses stem from the use of the RC4 stream cipher, combined with short, reused initialization vectors, making it possible to recover the encryption key by capturing it through traffic. So, I mean, I'm guessing that most of the time when we're talking about like wireless hacking attacks that determine the password, we're dealing with like weak protocols like WEP, right? So WPA is deprecated, introduced to address the major security flaws in WEP, primarily by implementing TKIP, Temporal Key Integrity Protocol, to improve key management. Still relies on RC4, but with stronger key handling. So this is still like an older protocol that you're not really going to see. And then we've got WPA2, which is widely used. A significant improvement that replaced TKIP with AES-based encryption, CCMP, remains the most widely deployed security protocol in both enterprise and consumer networks today. Okay, and the latest and greatest, WPA3, the latest security protocol providing enhanced protection against password-based attacks through simultaneous authentication of equals, SAE, and stronger encryption with 192-bit security in enterprise mode. Okay. Okay, Serpenter says Verizon as ISP. I mean, I'm not super familiar with American internet service providers because I'm Canadian. But Verizon is... How many companies do ISP down in the States? There are not very many of them, are there? Okay, Mama Rolf says category 7A is 10 gigabits per second up to 100 meters. And then 40 gigabits per second up to 50 meters. 40 gigabits per second seems... I'm not too sure how many ISPs are able to provide that kind of speed. Okay, so common Wi-Fi misconfigurations. Proper configuration of Wi-Fi networks. Oh, just a second. Gotta change up my music. Okay. That's a funny South Park reference right there. So in NYC, the main players are Optimum, Spectrum, Verizon, and Verizon Fios being the best of the bunch. I've only heard of Verizon. I haven't heard of Optimum or Spectrum. But I only know Verizon because Verizon is also like what is it called? Like a mobile provider, mobile service provider for like cell phones and stuff. Okay, proper configuration of Wi-Fi networks is crucial for maintaining security. Wi-Fi networks that are configured improperly could introduce weaknesses and increase exposure to wireless network attacks. Common weaknesses include the following: use of outdated security protocols such as WEP, use of weak passwords, use of unnecessary features such as WPS, use of default administrative credentials. Common Wi-Fi attack concepts. When Wi-Fi networks are insecure, attackers could attempt to exploit weaknesses in authentication or configuration. Common Wi-Fi attack concepts include the following: password attacks, brute forcing or cracking weak Wi-Fi passwords. Brute forcing or cracking. I wonder how practical it is to do brute forcing over Wi-Fi, because I'm pretty sure... I mean, I'm not too sure how much time it takes to do each one of these authentication attempts. It's something I've never tried before. WPS is evil disable it. I mean, I don't even know what it is. Rogue access points. An unauthorized access point that is connected to the network without the knowledge of the network administrator. This could be set up intentionally by an attacker or even intentionally by an employee plugging in their own router. Rogue access points. Evil twin attacks. Serpenter says, you guys have Rogers Network? I've visited Windsor and Toronto before. I mean, all of Canada only has like a very limited number of ISPs. So I mean, I'm pretty sure if you were to search up Canadian ISPs, there's something like 2 or 3. So there's Bell Canada, Rogers Communications, TELUS, and some other ISPs that I've never heard of that I guess operate on the East Coast. So Bell, Rogers Communications, and TELUS, these are the ones that I know. Okay, evil twin attacks. Creating a fake access point that mimics a legitimate network by using the same SSID. Unlike a rogue access point, which is physically connected to the target network, an evil twin operates independently and relies on tricking users into connecting to it, often to intercept their traffic or capture credentials. So this is something I have heard about. So evil twin attacks, making an access point with the same name, and there's also de-authentication attacks, forcing devices to disconnect from a network, which are kind of combined with these evil twin attacks. So the first thing you do is you create a access point with the same name as a legitimate one, and then you force all the devices to disconnect from the network, and when they reconnect, you might have devices reconnecting to the evil twin instead. Oh, the pineapple attack. Oh, are you talking about the Wi-Fi pineapple from like Hack 5? Traffic interception, attempting to capture wireless traffic if encryption is weak or improperly configured. Protecting Wi-Fi networks. Securing Wi-Fi networks involves proper configuration and monitoring. Below are some of the best practices involved in securing a Wi-Fi network. So use WPA 2 or 3 with a strong passphrase. Protects against unauthorized network access by ensuring that only authenticated devices can connect and preventing attackers from easily guessing or cracking credentials. Randolph says DAuth attacks were a thing before pineapples. I mean, I'm pretty sure that the pineapple made them... The pineapple just made it more popular because it was a consumer product that had that capability, right? Turning off WPS if not required. So this is what SysOS was talking about. So prevents attackers from connecting to a Wi-Fi network by using alternative authentication methods such as an 8-digit PIN. So this is an alternate method of connecting to the network, and I guess you should not use it. Changing default administrative credentials prevents attackers from getting administrative control of access points by using publicly known default usernames and passwords. Implementing network segmentation. So, for example, separate guest networks limits access to internal systems by isolating guest or untrusted devices from sensitive organizational resources. So I think this is something that's really good. This is something that's really good to do because you want to make sure that all of your secure devices are separate from all of the random people that are going to be joining the network in your guest network. SysOS says basically all WPS implementations are borked. Are they? Regularly updating firmware on access points. Protects against known vulnerabilities by applying security patches and fixes released by device manufacturers. Okay? Proper configuration significantly reduces the risk of unauthorized access and network compromise, while protecting the integrity of data being transmitted in both private and public networks. An attacker sets up a wireless access point with the same SSID as a nearby coffee shop's network. Unsuspecting customers connect to it instead of the legitimate network. What type of attack is this? This is the evil twin attack. Okay, and a network administrator wants to allow guest devices to connect to Wi-Fi without sharing the main password. Which Wi-Fi feature allows connection by entering an 8-digit PIN instead? This is WPS. So I think I understand what the problem might be here. So if WPS allows you to authenticate by using an 8-digit PIN, so my guess is that WPS is in insecure because it uses a numerical PIN, and because it uses the numerical PIN, then the PIN could be brute forced. WPS shares the password. WPS shares the password. Does it share the password when you authenticate, or when does it share the password? Does it share the password when you enter the correct PIN? Okay, between WPA2 and WPA3, which protocol is resistant to offline dictionary attacks? I mean, it has to be the later one. Serpenter says WPA3, WPA2 mixed mode for a guest network is for legacy devices. If you're using an iPhone 6 still, okay, prefer WPA3 enterprise settings. The PIN is used to encrypt the password. Okay, Bluetooth security. Well, I mean, I don't think too much about Bluetooth security, but I guess there could be a lot of sensitive information like flowing over the Bluetooth connection. So it's a technology that enables wireless communications between devices via direct pairing. It operates on the 2.4 gigahertz frequency and is designed for short-range communication. Common devices that use Bluetooth include the following. So we got wireless keyboards and mice, headphones and speakers, smartwatches and fitness trackers, vehicle infotainment systems, and IoT devices. Bluetooth is commonly enabled on personal and corporate devices, which makes it an appealing target for attackers. Classic Bluetooth versus Bluetooth Low Energy, or BLE. There are two main variants of Bluetooth, Classic Bluetooth and BLE. Classic Bluetooth handles heavier tasks like streaming audio and transferring files. BLE, on the other hand, is built for devices that only send small bits of data occasionally. Fitness trackers, smart locks, and beacons are examples of devices that use BLE. Think of classic Bluetooth as a phone call and BLE as a text message. One stays connected while the other one is quick and lightweight. Dracula voice, blah blah blah. Tracking, eavesdropping, data links. Serpenter says Jack Dorsey from Blue Sky wanted to create a messaging app over Bluetooth RF. A messaging app over Bluetooth RF. I don't. What is your opinion on Blue Sky? I know it's an alternative to Twitter. I've heard a lot of mixed messages about how well Blue Sky is performing as an alternative to Twitter. Okay, the security differences between the two variants matters as well. Classic Bluetooth goes through the proper pairing process where both devices agree on a shared key. BLE supports several pairing methods, but the most common one in a low-cost IoT device is called Just Works, which doesn't involve any user verification. This means an attacker can sit between the connection and intercept everything. The table below outlines key security differences between classic Bluetooth and BLE in different areas. The pairing model in classic Bluetooth is stronger and uses secure simple pairing with numeric comparison or passkey entry, providing a machine-in-the-middle protection. I've heard mixed messaging about Twitter 2. You mean Twitter 2 or you mean Twitter as well? Okay, so Bluetooth Low Energy is LE legacy pairing, cryptographically weak and vulnerable to passive eavesdropping, advertising and discoverability. So classic Bluetooth is lower risk and BLE is higher risk. Devices broadcast advertising packets continuously, which can leak device info, service UIDs, and sometimes unencrypted sensor data to anybody within range. That's no good. Encryption is stronger in BLE. Okay, and it varies in classic Bluetooth. Privacy and tracking is weaker because it uses a fixed MAC address. Trackable by anybody scanning for Bluetooth devices nearby. But BLE supports MAC address randomization. Okay, man-in-the-middle protection is better, and the attack surface is smaller in classic Bluetooth. So how Bluetooth devices pair and exchange data. Before two Bluetooth devices can communicate, they must go through a pairing process to create a secure connection. Older Bluetooth versions relied on a simple pin for pairing. A code would be displayed on one device for the user to enter on the other, or both users would agree on the same number and enter it on both devices. While this method is effective, short or default pins such as 0000 or 1234 were easy to guess, and the pairing process could sometimes be intercepted or brute forced by someone nearby. Modern Bluetooth uses stronger pairing methods. In classic Bluetooth, secure simple pairing was introduced in Bluetooth 2.1, which replaced pin-based pairing with more secure cryptographic key exchange. In BLE, newer devices use LE secure connections, which was introduced in Bluetooth 4.2 and also relies on cryptographic key exchange. However, older BLE devices running Bluetooth 4.0 or 4.1 still use LE legacy pairing, which provides weaker protection. How the pairing appears to the user depends on the device. Some devices ask you to confirm that the same number appears on both screens. Others may use an NFC tap, and simpler devices may pair automatically with little or no user interaction. The diagrams below show how each variant handles the pairing process. So classic Bluetooth, so the initiator does the inquiry. Broadcast to discover nearby devices. So a laptop is trying to connect to a headset. Connection request. Initiator sends connection request to responder. Capability exchange. Devices share supported SSP pairing features. Authentication. User confirms via numeric comparison or pass key entry. Link key generation. Both devices derive a shared encryption key. Bonding. Link key stored on both. Auto reconnect enabled. Versus BLE pairing. So we got a phone that is trying to connect to a smartwatch. Advertising. Peripheral continuously broadcasts advertising packets. Connection requests. Central sends connection request to peripheral. Pairing request. Central initiates security manager pairing. Peripheral responds. Key exchange. Keys derived via legacy pairing or LE secure connections. Encryption. Communication encrypted using derived keys. And bonding. Long-term key stored on both devices for future reconnection. Common Bluetooth security risks. Bluetooth communication could introduce security risks despite its convenience. Below are common security risks that affect Bluetooth-enabled devices. Unnecessary discoverability. Leaving devices in discoverable mode can be detected by nearby attackers. Weak pairing mechanisms. Older devices that use simple PIN codes may be vulnerable to brute force attacks. Unauthorized pairing. Attackers may attempt to pair with devices if user approval controls are weak or misconfigured. Blue jacking. Sending unsolicited message to Bluetooth-enabled devices. You know, I heard about something. I don't know if it actually has anything to do with Bluetooth necessarily, but it kind of reminded me of like a feature on Apple devices. But anyways, we got ads running on Twitch right now, so we'll put on the birds, and we'll be back in about 60 seconds. So enjoy the birds, and we'll be back in just a bit. Okay, so it looks like we've got some attempts to name these birds. Well, I mean, we'll just leave it up in the air for right now. Okay. So so this conversation about Bluetooth has reminded me of like a vulnerability in iOS devices. So there was like something called I think it was called AirDrop. Allows an iPhone to broadcast a file. We can rename them each stream, of course. Let's see. Broadcast a file to all devices within range. And it was used for like some sort of harassment. AirDrop is still in there, but it used to allow anyone to transmit to anybody. Yeah, let me do a quick search on that. iPhone AirDrop. Harassment. Okay, unwanted advances, apples, memories, and iDrop pose. Okay, memories? There's something called memories as well? I mean, the cyber flashing. Here's a... I mean, I don't know if I want to open up this article because it might have something weird inside. Let me take a look in another tab just to make sure that this Wikipedia article doesn't... Okay, so there's no... There are no pictures. There are no pictures associated with this Wikipedia article called... No. There's occasionally obscene... Well, there's occasionally, like, adult contents on Wikipedia articles. So cyber flashing involves sending obscene pictures to strangers online, often done through Bluetooth or AirDrop transfers between devices. Okay, so the first mainstream coinage of the term occurred about August of 2015, after a female commuter was airdropped 2 pictures of a member. That's great. Indicated that as the pictures were declined, insufficient data... The pictures were declined, so insufficient data was recorded by the receiving phone and could not provide suitable evidence. That's... Okay, an appropriately equipped device can seek out any active peers within about 10 meters. So you have to be really close to the people that you're sending these to, because it's something that is done over Bluetooth. Don't think of it as a... Yeah, think of it as zeros and ones. Yeah, I guess if you think about it that way, then there's no problem with any of these files, huh? Anyways, so this kind of thing can happen over Bluetooth, and well, I mean, I'm not too sure if it can be done over like modern Bluetooth devices, but AirDrop is something I heard about. You can drop an RCE payload. That would be a problem. Oh, it would be a problem though, wouldn't it? Okay, anyways, let's move away from these topics. So, bluejacking, blue snarfing, attempting to access data through a Bluetooth connection, blue bugging, exploiting a vulnerability in a Bluetooth connection to gain control of a certain device, lack of device updates, outdated Bluetooth implementations may contain known vulnerabilities. I mean, the thing about Bluetooth devices is that people don't know if the updates aren't happening automatically. People wouldn't go to their way to update their Bluetooth devices. And hey, an appropriately named user has just followed on Twitch. Thank you very much. Okay, let's see. Attackers who attempt to exploit Bluetooth weaknesses must be within the device's proximity. Came in from the YouTube video. Hello, nice to see you here. Places such as offices, conferences, and airports where Bluetooth attacks could often take place. Security considerations for classic Bluetooth and BLE. So both classic Bluetooth and BLE devices should be configured and managed carefully to minimize exposure to security risks. The table below outlines some practical measures that can help and whether they apply to classic Bluetooth, BLE, or both. Disable Bluetooth when not in use. Avoid leaving devices in discoverable mode. Okay. Use modern Bluetooth versions. Require user approval for pairing. Avoid pairing in public places. Remove unused paired devices. Keep devices updated. Monitor BLE advertising data, and avoid just works only in devices with sensitive environments. Okay. So even though Bluetooth has a limited range, don't let that give you a false sense of security. A vulnerable device can still leak sensitive data or give an attacker a foothold into a wider network. Think of it like leaving a window slightly open on the ground floor. It might seem too small an issue to matter, but it's often enough for someone determined to get through. Okay, Serpenter says, I also manually turn off airdropping sharing unless I need it. I mean, it's probably a good It's probably a good policy to have. Always check and make sure Bluetooth is off. Apple turns it on automatically after updates. That seems like kind of a jerk thing to do. Okay, so a user is connecting a new pair of wireless headphones to their smartphone and is asked to confirm a 6-digit code displayed on both devices. What is this step called? Okay, what is this step called when you exchange? Pairing request. No, this is BLE. So let's see, this is authentication? This is probably authentication. Well, actually, pairing probably fits better. Okay, what frequency band does Bluetooth operate on? So it operates on 2.4 gigahertz. Okay, an attacker within Bluetooth range gains access to the victim's phone and downloads their contacts and messages without authorization. What type of attack is this? So they gain access to the victim's phone and download their contacts and messages. So this is blue snarfing, I think? It's called a mean attack. That is a mean attack. Okay, so RFID and NFC security. This is something that I've never really thought about too much. Especially like NFC, because it's got to be... Although... Okay, let's take a look. So, radio frequency identification, RFID, is a technology that uses an electromagnetic field to identify and track tags attached to objects. Near field communication, NFC, is a closely related standard that enables two devices to exchange data when brought into close proximity. Both technologies allow wireless communications over short distances, but they differ primarily in range. RFID devices can transmit radio waves up to 100 meters or more, depending on the tag type and frequency band. NFC devices, by contrast, operate only within approximately 5 centimeters. The image below highlights the key differences between RFID and NFC. So they both operate on low frequencies, and for NFC the range is only 5 centimeters, but you have up to 100 meters with RFID. So the communication is two-way in NFC versus one-way in RFID. Okay, so common uses of NFC include contactless payments, phone pairing, and transit cards. For RFID, it's access badges, inventory tracking, and asset management. 13 megahertz versus 125 kilohertz. Megahertz, okay. Range comparison. So RFID can go much farther than NFC. How RFID and NFC work. An RFID system consists of two components: a reader or interrogator and a tag. The reader emits radio waves, and when the tag enters the reader's field, it responds with stored data. Tags can be passive or active. A passive tag has no internal power source and draws its energy from the reader's electromagnetic field, which limits its range but makes it inexpensive and long-lasting. An active tag contains its own battery, enabling it to transmit over much greater distances, but at a higher cost with a limited lifespan. The following diagram illustrates how communication in an RFID system works. So RFID, so there's the reader. In a passive tag, it is powered by the reader, and it can only transmit in a short range from centimeters to around 10 meters. But in an active tag, the two devices communicate with each other, and they can communicate over long distances up to 100 plus meters. NFC operates on a specific RFID frequency and supports two-way communication between devices. One device generates an RF field, and the other either responds passively or generates its own field to complete the exchange. This bidirectional capability is what allows NFC to support interactive use cases such as contactless payments, transit cards, and device pairing. Both technologies are designed for quick, simple interactions that do not require manual connection to a network. The following diagram illustrates how communication in an NFC system works. So, initiator device generates an RF field, and the target device responds to the field. So the initiator device sends the RF field and the data, and the target device sends the response data. And this happens over a very short distance of less than 5 centimeters. RFID and NFC are commonly used for identification, access control, and contactless transactions. Employee badges, warehouse inventory tags, hotel keycards, and payment terminals all rely on one or both of these technologies. RFID and NFC security risks. The following techniques are commonly performed by attackers to exploit RFID and NFC weaknesses: eavesdropping, intercepting communication when an access card is scanned, cloning, copying data from one card to another, relay attacks, forwarding communication between a legitimate card and a reader to bypass the distance limitation that would normally prevent the interaction, unauthorized scanning or skimming, secretly scanning a card without the owner's knowledge to steal data, lost or stolen cards. A lost employee badge could be used to enter an office or building if access rights are not revoked. An example of a relay attack involves a contactless payment card stored in the victim's pocket. One attacker holds a device near the victim to pick up the card's signal, while a second attacker holds another device near a payment terminal in a shop. Wow, this sounds pretty devious. The two devices relay the communication in real time, causing the terminal to process the transaction as though the card was physically present. So they could scan your card and use it to pay for something that is farther away. All right. The following diagram illustrates how a relay attack is performed. Okay, April says, I was going to train a model on your voice for you. As a joke, I should have. This works. I've seen videos of it. It's kind of frightening because everybody uses NFCs for contactless payments with their debit cards and their credit cards. Reader captures card data at close range from the victim's pocket, I suppose, and then attacker 1 they relay the information over to attacker 2, and attacker 2 pays for something. I mean, the interesting thing is that the emulator device probably doesn't look like a card. So if people are paying attention when they're making the payment, they should be able to identify that it's not a card that's being used. Okay, also the network in a Tesla car. I mean, there are all sorts of possibilities. Security considerations for RFID and NFC. A multi-layered approach is required in order to secure RFID and NFC devices, which requires protection of data during transmission, and securing physical access to the devices. The following measures could help ensure that exposure to risk is minimized. Use cards that support encryption, limit sensitive data stored on cards, or use tokenization. Immediately deactivate lost or stolen cards. Use protective sleeves, such as Faraday pouches, to protect against unauthorized scanning. Update access controls regularly. Implement secondary biometric authentication where possible. Okay. So an attacker reads the data stored on an employee's access badge and writes it to a blank card. What is this technique called? So this is cloning. People use NFC from phones too. Oh, that's true. What does this device look like a phone though? Okay, a deploy device could look like a card with some wires that you can hide. An employee reports their access badge is lost. To prevent unauthorized building access, what should be done to cancel the... What should be done to the card's access rights? They should be revoked. Wait, what kind of acts are they looking for? Because it doesn't tell you how many... Deactivate. Okay, maybe deactivate? Nuke from orbit? Maybe. Okay, other wireless technologies. Okay, we got smart lights, motion sensors, smart hubs, door locks, thermostats. I mean, these are not using... Oh, interesting. Let's take a look at these. So we got Zigbee, Z-Wave, LoRa, cellular, and infrared. So infrared, for example, could be like a remote control in a television. LoRa, I think I've heard of the LoRa network before. So LoRa long range gateway, so this leads to IoT devices like sensors and streetlights. Zigbee, Z-Wave, I mean, I've not, I don't know very much about these other technologies. So a smart hub, I'm guessing this is like this is kind of like Wi-Fi, right? So door locks and thermostats, motion sensors and smart lights. LoRa is line of sight light communication. Zigbee and Z-Wave are for IoT devices. Okay, in addition to Wi-Fi, Bluetooth, NFC, and RFID, there are many other wireless technologies that are used in modern environments. These technologies support smart devices, automation systems, and connected infrastructure. So several wireless technologies are commonly used in smart environments and Internet of Things systems. So LoRa is not light, it's still radio waves. Okay, well, I mean, we'll figure it out in just a second. Zigbee. Zigbee is a low-power, short-range protocol commonly used in smart home devices, such as lights, sensors, and smart plugs. It operates on a mesh network topology. Each device can relay data to its neighbors, extending the overall range of the network. And there's Z-Wave. Serves a similar purpose to Zigbee, but uses a more standardized protocol and offers a wider communication range. It is common in home automation systems that control thermostats, blinds, lights, and security sensors. And we've got LoRa. What is LoRa? Designed for long-distance, low-power communication, it is used in IoT deployments such as environment monitoring systems, agricultural sensors, and smart street lighting, where devices transmit small amounts of data over distances of several kilometers. Okay, and is this a link? If I click on this. Okay, so we've got more information here. So low rank adaptation, fine-tunable technique that adds a number of trainable parameters to a pre-trained... I don't think we're talking about this. Thank you very much, Hanzo, for following on Twitch. Thank you. Okay, so cellular. So LTE-M, NB-IoT. Cellular technologies allow devices to send data over existing mobile networks by connecting to nearby cell towers. In the same way, a smartphone connects to the internet when Wi-Fi is unavailable. Smart meters, vehicle trackers, and remote industrial sensors commonly rely on cellular technology. TryHackMe's bot went weird. Yeah, I guess it did. Infrared. Infrared uses light signals for simple line-of-sight communication over very short distances. It is found in remote controls for televisions, air conditioners, and projectors, though it has largely been replaced by radio-based protocols in newer devices. Security risks in emerging wireless ecosystems. Because IoT devices are often small and inexpensive, security is sometimes not prioritized during design or deployment. As more devices connect wirelessly, new security risks may arise. The following table describes known security risks associated with the wireless technologies introduced in this task. This is not an exhaustive list, as a full treatment of each protocol's attack surface is beyond the scope of this room. So what's happening with Zigbee? So when a device without a pre-configured key joins a Zigbee network, the coordinator may transmit the network encryption key protected by only a well-known default linking key. An attacker sniffing the network during this pairing window can recover the key and decrypt all subsequent traffic. The mesh topology amplifies this risk, as a single compromised device can relay malicious commands to every other device on the network. That's great. Okay, Dapril says, did I completely hallucinate a protocol that uses line of sight and light? I mean, I don't know. Researchers exploited the Zigbee protocol in Philips Hue smart bulbs, taking control of the bulb and using it to install malware on the Hue bridge, which then provided access to the wider home network. You got in through the smart bulb? Okay, sure. Z-Wave uses a security framework to protect the encryption key exchanged during device pairing. The original framework encrypted this key using a static value of all zeros, making interception trivial. Okay, and what did they do with Z-Wave? Researchers demonstrated the downgrade attack, dubbed Z-Shave, against a Yale smart door lock, extracting the network key and getting persistent access to the lock. I mean, if you have access to a smart lock, does that mean that you can unlock the door at any time you want? Because that sounds pretty sketchy. LoRa. Devices activated by personalization, ABP, use static session keys that remain unchanged unless manually rotated. If the frame counter resets after an overflow or device reboot, an attacker who previously captured traffic can relay old messages within the counter's acceptance window. Devices deployed in remote, unattended locations are also physically accessible to tampering and key extraction. Researchers demonstrated a replay attack against LoRaWAN 1.0 devices, desynchronizing frame counters between a sensor and the network server and cutting off legitimate communication. Okay, so is this just a DOS attack then? So the replay attack desynchronizes the frame counters. It cuts off the legitimate communication. Okay, I mean, I guess you can take the devices offline. Cellular. Okay, you own the lock. So cellular. What happened with the cellular stuff? So a 2021 study from Purdue University demonstrated that attackers could identify cellular IoT devices on the network and exploit their low-power sleep modes to launch targeted denial of service and data interception attacks. It could be a man in the middle or even something to affect IPC systems. Infrared. Infrared signals carry no authentication or encryption. An attacker can capture a signal from a remote control and replay it to operate the target device. Because infrared commands follow fixed, publicly documented protocols, such as NEC and RC5, an attacker can construct valid commands from the specification without needing to capture any signal at all. So, I mean, we've heard about devices being used to turn off televisions. So you can turn off or turn on a television, or you can open a garage door because it's using infrared as its signal. Researchers used a Raspberry Pi with a low-cost infrared transceiver to record and replay commands, controlling televisions, air conditioners, and set-top boxes from across the room. Okay. So use install codes for Zigbee device pairing. turn off S0 compatibility for Z-Wave controllers, use over-the-air activation for LoRaWAN devices, restrict access to cellular IoT gateway management interfaces. Infrared can carry encryption, it's just not often implemented and not in typical devices. I mean, I guess if people got really serious about it, it could become more commonplace. Deactivating unused infrared receivers on network-controlled devices reduces risk of replay attacks or command injection. Segmenting IoT devices onto dedicated network segments. So your IoT devices should be on their own network, because IoT devices run the risk of being compromised through lack of security updates much more frequently than other devices. Okay, so a homeowner installs smart lights and motion sensors that communicate with the central hub using a low-power mesh network. Which wireless technology from the task best fits this scenario? So this is Zigbee? Okay. Between S0 and S2, which Z-Wave security framework is vulnerable to a key interception due to the use of an all-zero encryption key? So that's like S0. Okay, and SysOS says there was a device from the 90s that used it to differentiate between multiple remotes and users. April says, makes sense, these are layer 2, I would imagine that you can add encryption on top of anything if you have the compute and bandwidth. Okay, so I guess we're gonna take a test. An interactive exercise is available on the static site attached to this task. Click on the View Site button to launch the activity. Okay, let's go ahead and take a look. Let's put this in full screen. Okay, match the attack. Each scenario below describes a wireless attack covered in this room. Select a scenario to begin. Okay, so attack scenario. 2 attackers use relay devices to forward the communication between the victim's contactless payment card and the shop's payment terminal in real time. So this is NFC. So they're talking about a relay attack. Where is it? NFC? Correct? Okay, great. An attacker reads data from the employee's access badge and writes it to a blank card, producing a working copy that opens the office door. So this is RFID. So this is RFID cloning. Okay. So an attacker captures the 4-way handshake. Thank you very much for following on Twitch, RazorSun. Thank you. An attacker captures the 4-way handshake between a client and an access point and runs a dictionary attack offline to recover the network password. So this is some sort of Wi-Fi attack. So this is Wi-Fi? Okay. An attacker sniffs the network during device pairing and recovers the encryption key, which was only protected by a well-known default value shared across all devices. So pairing, I mean, the only technology that we're dealing with that has pairing is Bluetooth. Oh, this is not Bluetooth? So is this like Zigbee? Yeah, I thought it was Bluetooth. Okay, let's do another one. So an attacker records a signal from a remote control and replays it to operate the target device from outside a window without needing any authentication. So this is infrared. Okay, and an attacker within range connects to a victim's phone without authorization and downloads their contacts and messages. So what do we have left? We have Bluetooth. I guess this is Bluetooth then. And the last one has to be Zigbee. Okay, so my flag is wireless threats identified. Sure. Alright, and then we can go back and submit the answer over here. Okay, and the conclusion. So in this room, we've covered the fundamentals of wireless networking at a high level, including the different types of wireless technologies in wide use today. We've also covered the security risks that come with these technologies and the measures that can be put into practice to reduce their exposure to threats. The foundational knowledge from this room prepares you for rooms that explore wireless attack scenarios in greater depth. To further explore wireless attack, network attack concepts, complete the following rooms: Wi-Fi Hacking 101 and Intro to IoT Pen Testing. So key terms, great. That's a lot of word salad. Mark is complete. Okay, are they gonna give me my big completion message? And I'm 2Nobody. Hello, nice to see you here. They didn't give me my big congratulations message. That's unfortunate. Okay, so how much time do we have left? We could probably do like another 60 minutes or so. Let's do like a CTF box challenge or something, because I haven't done any of that in a while. Okay, let's try some EchoCTF.red. So EchoCTF.red is a website that you can mostly access completely for free. And they've got a bunch of really cool exercises after you've connected to their network. So let's try some Offensive 2024. So I don't know if I've done any of these machines before. Okay. Not too many machines. Let's try this one called Cashier. And it's mostly safe to use too, mostly. I mean, yeah. Okay, so the first thing we need to do is we need to connect to the network. So we can use like a VPN key to access the network. Okay, so EchoCTF over here. We'll just use some OpenVPN. Have I ever used Pwn Till Dawn? Yeah, I have used Pwn Till Dawn. The problem with Pwn Till Dawn was that there were a lot of machines from Pwn Till Dawn that they don't allow people to do walkthroughs of. So they don't let people do write-ups on them. PwnTillDawn.com. Okay, let's just search for it. Pwn Till Dawn's online, okay. The other thing about Pwn Till Dawn is that I don't think they've updated their network in a really long time. I'm pretty sure the service came out like 2 or 3 years ago, but they haven't really updated their machines. They haven't added any, they haven't modified any. Anyways, okay, so we should be connected to the network now. We've got an IP address on the TUN interface over here, which means we're probably connected. So the only thing we need to do now is start up the machine. Your one-stop POS and OCR mayhem platform. OCR. That kind of reminds me, there are, anyways, we'll figure it out. Power up the target. Did they fix our recent vulns though? I mean, I don't know. I haven't used the service in over a year. Whoops. Okay, Cashier is powered up. So smile and take a picture. Do not forget that we have a one-of-a-kind OCR backend that will read anything written on an image. Oh, I think I have done this I have done this box before. So I think this was the box where we were trying to get payload to run from the OCR software. We uploaded like an image to the target, and we were supposed to get it to run like a payload based on the OCR. Okay, so I think we spent a long time stuck on this machine. I'm pretty sure last time we were looking at it. So maybe we'll select a different target. Serpenter says, the Blue Jays in my yard are the same ones in the Blue Jays team logo. Yeah, those are the Blue Jays that you see on the West Coast. Okay, let's try... Well, this one's called Pizza Dough. Maybe we'll try this one. Dough, I need pizza, one with oregano and celery. Excuse me, sir, but would you like some oregano and celery with your pizza? I mean, oregano okay, but I don't know about celery. Okay, let's start this one up. Okay, so let's take a look. Alright, so we got 5 flags on the system, and we got an IP address. Alright, so the first thing we're going to do is we're just going to give it an nmap scan. And we'll see what we get, what we discover. So we got port 22 and port 80, which is pretty normal. And in the meantime, let's put on some new music. Maybe this stuff. Port 22 and port 80. Well, I mean, port 22 is SSH, so that's like remote login. Port 80 is a web page, so we might want to check out the web page manually over here. Oh, PHP, my favorite programming language. Okay, so what do we have on here? So it looks like we've got some sort of online ordering application. We got oh, there's a shop. That's interesting. This is the content I've been looking for, and Kuzumaki, hello, nice to see you. Hope you're having a good time. Okay, let's see if I can pull up some music to play. Maybe some Mass Effect. Here we go. Man, am I hungry. I mean, we're looking at pizza. I guess that would make you hungry. Okay, so we got login and we got administrator login. Can we make an account? So in any application where you can make a new account, you should try to make a new account and see what we can look at. So we got first name, last name, HackerFrog, contact. Are they looking for an email address? Are they looking for a phone number? 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 0, like that. Address, anywhere you want. Email, hacker@frog.com. Password, Pizza Hut party language, love it. Okay. So let's see, password, we'll make it something super secure, and then we'll create our account. Did we make an account? I can't tell. Okay, do not use example.com. I mean, could be anything, right? I'm not too sure. Huh. We see this message over here. It says Oret Nom 23. We might want to add that to our users list. Echo users.txt Oret Nom 23. Okay. So I'm trying to create my account, but it's not letting me. It's not allowed to work, example.com, really? Maybe contact, they're looking for like a username. You don't have an item in your cart yet. Do we need to have an item in my cart to create an account? Okay, so we're logged in as HackerFrog. And we need to add stuff to our cart. So we'll add one pizza. So the other thing about this particular application is that they were mentioning something really weird, which was, what was it? Oregano and celery on your pizza. We might want to might want to look out for that. Yeah, this application is really acting really slow. It might be because of the Nmap scanning. Anyways, I'll stop the Nmap scanning. Instead, we'll try some other scanning instead. We'll try some directory busting. But before we do that, let's take a look at our profile page. So the profile page... Oh, interesting. There's a specific email here as well. Okay, so we'll... So the email that we got is oretnom23@gmail.com. What happens if we just Google search for this username? oretnom23? Oh, interesting. Okay, e-commerce site using PHP. We might want to do a little bit of search on this. So oretnom23 pizza. So CV online pizza ordering system vulnerability. So I mean, this could be what we're looking for. So online pizza ordering v 1.0 was discovered to contain some sort of vulnerability. Sure, let's take a look. Actually, maybe we can do some research over here. We can look for pizza. So online pizza ordering 1.0 remote code execution. This might be what we're looking for. So we'll copy over the script. There are two possible ones we could be looking at here. Either the unauthenticated file upload or the remote code execution. So we'll try this one first. And we'll also take a look at this other Python script. Okay, so the first one is the text file. So it says here, the malicious user can request an account from the administrator of the system. He can then use the vulnerability to destroy or get access to all accounts on the system, or even more, worse than ever. What? The malicious user can upload a very dangerous file on the server, and he can execute it via shell. This is because he can access the upload function from the administrator account. This status is critical. Okay, so we got some sort of SQL vulnerability. We got what are we looking at here? So streamable.com. I mean, I don't know what the heck this website is. Let me put it in another browser tab. Oh, it's a video. Streamable.com is a video website. Okay, and then we've got this GitHub URL right here. Yeah, this is exactly what we're looking at. So we're looking at some SQL injection. Malicious user can request an account from the administrator of the system. Okay, injection request. So we go over to PHP OPOS admin ajax.php, and what are we doing? Okay, reproduce. Okay, so this is probably related to the Python script over here. So let's see, online pizza ordering system 1.0 unauthenticated file upload. I mean, unauthenticated file upload, we can turn it into like a web shell. Okay, this is Python 3 script. OS requests arg parse beautiful soup. And we're using some sort of PHP web shell. Send a post request to the server. Send a GET request to the server. Okay, so I mean, we got the script. We can. Why is there an asterisk over here? Can you do a crypto lock or ransom request at some point? I mean, could we? So why was there an asterisk appended to this script? That seems kind of weird. Let's rename this thing. pizzapone.py. Executable? I don't think it is. Okay, enter URL with HTTP. Enter URL with HTTP. So we're looking at this thing, right? Enter file path for the PHP web shell. I don't know. TMP? Shelled, I don't know where are we going to put this. Okay. Is it directory error? Is it directory? So do they want us to supply like file path PHP web shell? Yeah, I don't really understand what the heck is going on with this script. Let me take a closer look. Okay, so we can add arguments to the command line. So the URL with help PHP web shell. So the payload PHP web shell, are we supposed to give it PHP code? Oh, you're supposed to provide it with a web shell PHP script. Okay, well, I mean, if that's the case, we could probably get one from like RevShells or something. RevShells.com. And let's see. I mean, the smallest one is this one. Okay, we'll run it again. So the URL is this one. And the PHP enter file, but it says file path though. Enter file path PHP web shell. So it's not actually looking for, I don't think it's looking for a payload. Yeah. Okay, if no arguments are passed, ask the user for them. So enter URL with the HTTP URL, great. Input, enter file path for the, so args.payload. So args.payload is, how are they using it in the script? We should probably, a file with the payload in it. A file with the payload in it. Okay, let's take a closer look. So where else is the payload argument being used? So file name equals os.path.basename args.payload. OS path. So are they talking about like a local file? So files equals img filename.open application octet stream img. So this is the thing that's going to be uploaded. So local in the system running the script. Okay. All right. Let's try. Shell.py. Well, we'll make this thing shell.php. Okay, paste this in. Then we'll run the script again. We supply this. And then we provide the path to shell.php. Okay, so uploaded file found. Full URL of your file is this. So if we can actually access this, this means we've got remote code execution. Okay, so it looks like we can access this. So 0 equals who am I? Bam! We've got remote code execution. So we're currently running as the www data user. How much time do we have left? We've got 42 minutes. I wonder if I can finish this box in under an hour. Hackerman. Shin BDR, hello, nice to see you here. We just did some file upload attack. Okay, and so I guess to get additional access, we probably want to create a remote a reverse shell binary. So we'll reverse shell binary with this IP address using MSF Venom. Pretty standard for what I do. And then we'll serve this up. Which box is this? This is the pizza box? Pizza dough. Pizza dough on PicoCTF. Okay, so we got rev.elf, and we'll just serve it over here. Python m HTTP server on 80. And then we'll run a wget command. Wget from our server rev.elf. And in the meantime, we can set up our... Uh-oh, this is room. Should be running it from here. Never mind. Okay, Jackson, America, hello. Why do you have to make it so obvious that I'm a Canadian there, Jackson? Nice to see you here. Okay, so we'll just listen on Penelope. And we'll RL wrap this. Because I noticed one thing that's kind of not great about Penelope is that there's no command history for Penelope. It'd be nice if we did. Okay, so we got Penelope working here, that's good. And then, let's put on some birds. How about... We're going to take a break because there's ads running on Twitch right now, and let's just put on these birds. Okay, we'll be back in about 40 seconds. What names do these birds have? Hard to say. So if you're interested in learning more about these birds, I guess we can give you a link. These are Stellar's Jays. Just a second. Why are you always asking for my location? And why is Wikipedia in dark mode all of a sudden? These are... These are the woodpeckers. This guy right here. If you want to read up more on them. Birds aren't real, AI dinosaurs. Maybe. Okay, what were we doing? We're trying to get a web shell. Okay, so we'll run this command from the web shell over here. Where do we have our access? It's over here. Okay, so we'll run this command to download the file. So does it download? If we look at our local web server, yeah, it did download. So the next thing we need to do is we need to make it executable. So that's the chmod command 777 on rev.elf, and then we need to execute rev.elf. And I think we've got our initial access. Okay, awesome. Okay, I don't know if that was true of all woodpeckers, but apparently their tongue buffers their brain. Yeah, that's pretty common to woodpeckers. Alright, we've got initial access, so I can ask who am I? Ooh. Warning, RL wrap appears to do nothing for Penelope, which asks for single key presses all the time. Don't you need always read line and possibly no children? Okay, so I mean RL wrap is doing something for Penelope, because without RL wrap, Penelope doesn't have command history. So it is doing something, so it's a good thing to you. Anyways, let's call in Mr. Scary Hacker Voice Man to talk about how we got into this system. Because I don't get very many occasions to call the guy in.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes in every time we break into a server, and we just broke into this one. Well, Mr. Pizza Dough Administrator, it seems like you enjoy deploying applications that have been proven to have known vulnerabilities. That is a big mistake. We managed to discover a script that deploys a web shell to your application, and which we leveraged into a reverse shell. Maybe you knew about the security flaws in your system, or maybe you decided to accept the risk. Well, you accepted the risk. And now we're in.
Okay, so we managed to get in through like a known exploit for this particular application. So what we need to do now is we need to figure out what is this? Okay, so our user www.data can run the following commands on pizza dough. We can run the oregano binary. But what does the oregano binary do? We have no idea. I think what we need to do first is we need to get the flag for the ETSCTF user. It's a directory. Oh, okay. CD ETSCTF. There's no flag here. Okay, so something with celery, maybe. So we know that there's a bunch of flags on this box. So it says there's an application flag, there's 2 system flags. There's supposed to be 5 flags. Oh, there's probably a flag in the etc password file. So here we go, there's 1 flag. So we just need to submit this. What do we mean by factory hacking? So we were doing like a TryHackMe module on operational technology in ICS, industrial control systems. So that's what we meant by factory hacking. Okay, so that's one flag. And the next flag is probably one in the HTML directory here. We have the admin login.php readme.txt. Okay, image is used. We also have like an admin directory in here, which we haven't looked at yet. So dbconnect.php might have some interesting information in here as well. OPO user, OPOS password. I mean, I don't know if this is going to be relevant, but we might as well copy this password. The other thing we could look at is, I don't think there are any other like standard. There are no other standard users on the server. What's in the database? Not exactly sure. Let's just add this password to potential passwords over here. And let's take a look at that oregano binary. I think those would relate to the...
I'm system root.
Thank you for redeeming the I'm root redeem. We're not root yet, but we're trying to get there. Okay, so local bin oregano. What is this thing? So we can run this as root, but what is this file? So file command not found. So this is a root-owned binary that is readable. So we can read this. Well, let's take a look at it. Oh, this is a Python script. Okay, so it imports... So from celery.backends.base, import backend. Okay, so... Yeah, it does have to do with celery and oregano for some reason. Backend equals celery. Is there celery on the system, though? So is this part of the... Okay, so we've got environment reset, secure path, use PTY. I've heard of that before. No idea what it is off the top of my head, though. You've heard of celery before? Well, let's do a quick search. What is Python celery? Okay, Python celery is an open source distributed task queue used to process vast amounts of messages and tasks asynchronously in the background. Okay, core use cases, background jobs, scheduled tasks, heavy computations, horizontal scaling. And NetDBG, hello, nice to see you here. What is up? Hope you're having a good stream. Or hope you're having a good evening. Okay, so exec module backend, import backend. Backend, what is the backend? B equals celery. B dot exception to Python exec. B dot exception to Python. Backend exception to Python. Okay, let's do some search. So Python celery, backend, exception, what is it called? Exception to Python? So this is some sort of function. Okay, in the celery distributed task queue, exception to Python is a method within the base backend class responsible for converting a serialized exception starting the result backend back into a native Python exception object. Okay, there is a security vulnerability. So this method was at the center of a significant remote code execution vulnerability. Prior to Celery version 5.2.2, an attacker who could manipulate the metadata... Wait, where is it? Manipulate the metadata in the result backend could force exception to Python to dynamically load any Python class, instantiate it with arbitrary arguments, potentially leading to system takeover. Remediation was Celery 5.2.2 plus? I'd assume that's a catch exceptions. Alright, so I guess what we need to do is we need to figure out the version of Celery that's being used. So how can we figure out the version of modules? Version of modules. Python module version number enumeration. Okay, enumerating Python module version numbers can be done through the command line or directly within a script. So let's see. Pip list, pip freeze, pip show. Enumeration via code. The version attribute. The version attribute, many third-party packages follow pep and a version string. Okay, so print something something dot version. Okay, let's give it a try. So back over here, Python 3, import celery. Print celery dot version. .2.1. Okay, so this is a vulnerable version of Celery that we're dealing with here. So we can just exit. So how do we build this? How do we build this chain? So CVE 2021-23727. Well, let's do some research on this. Okay. So it's a critical stored command injection vulnerability affecting the popular distributed Python task queue Celery. Versions prior to 5.2.2, it allows a malicious actor with access to the result backend to achieve remote code execution on the system. Okay, by default, Celery's exception to Python method relies on trusting messages and metadata stored in the result backend, so result stores. If a task fails, Celery serializes the failure information in the backend. An attacker who compromises or manipulates the backend can craft a malicious directory structure. When the producer pulls the task and Celery attempts to reconstruct the exception class, it is tricked into deserializing the malicious payload and executing system commands. Okay, so where can I find a working payload? OS command injection in Celery. So we got a... we've got a GitHub advisory, but it's not necessarily going to give us the exact payload. Well, let's take a look. Okay, so it doesn't tell us how to do it. Okay, let's try asking our good friend the AI. The thing about... Yeah, we could search for a POC. Okay, so let's see, this thing in detail. Here's a security company. Yeah, we can look for the POC on GitHub as well. But it all kind of points back to this advisory. The other thing we could do is we could search for this in the exploit. Okay, nothing here. And we could also try looking at exploit.db. Oh, is this paywalled? This is paywalled. They want us to book a demo, huh? Okay. Let's just try asking the our good friend the AI. At a CTF where the system is affected by this CVE. If I wanted to write a POC that prints hello world, what steps would I take? Paywall all the things. Yep. Stored command injection in the result backend. Dangerous path for exception to Python, reconstructing an exception from the attacker controlled backend metadata. I can't help you craft an exploit payload or a POC that executes command, including one that prints hello world. Okay, well... A safe CTF validation is to prove that your crafted metadata reaches the vulnerable reconstruction logic and is rejected or handled differently after patching. After patching, you say. Okay, the advisory examples show that a malicious backend entry could make Celery behave as if it were calling something like os.system. This is dense, but here's a POC. Did you find a POC, April? Okay, so wait. Gemini will give me my payload? Okay, sure. By default, Celery attempts to reconstruction exception classes. Conceptual payload structure. The payload is a dictionary structure that dictates the module to access. So there's a dictionary here, exec module OS, exec type system, exec message your malicious command here. Okay, so example scenario, if an attacker manipulates a task's results in the database, they can replace the normal failure details with a dictionary like this one. Okay. So when the producer pulls for a result and Celery processes the data in exception to Python, it treats os.system as the exception type and passes the malicious string as the argument, which executes the shell command with the privileges of the running process. Okay, so let's try to understand what's going on. If an attacker manipulates a task's results in the database, okay, let's take a look at closer look at the actual script that's being run here. So let's copy the entire script and then let's put it on our system so we can take a closer look. Okay. So what we're doing here is we're giving exec module system argument 1. System argument 2 is the exec type, and the exec message is system argument 3. So according to this, we should provide OS is the first argument, system for the second argument, and then our desired command for the third argument. Okay, let's give it a try. So sudo user local bin oregano, and then the 3 arguments. Argument 1 is OS, argument 2 is system. Argument 3 is going to be echo pwned and redirect it into temp test.txt. Okay. Paste in the oregano code and ask how the Celery POC interacts with it. Maybe another time. Let's see if actually something got written out to the temp directory. Okay, that worked. So all we need to do is supply 3 arguments. OS, system, and then the command we want. I mean, we've got... I mean, what can we do? We could probably just make a root bash. We can make a root bash and then copy it over to the temp directory. So the easiest way to do that would be to do something like... Let's think about what the root bash payload looks like. So it's copy bin bash to temp root bash, and then chmod u plus s, I think. Chmod u plus x temp root bash, and I think that's it. But okay, but before we execute on this, let me see if I've got the payload correct. Okay, so the payload is going to be this. Happy coding? Well, I mean, we're trying. So copy bin bash to root bash, and then chmod it. Do you know French? I know very little French, so I'm going to say no. Copy bin bash to temp root bash, and chmod u plus s to temp root bash. So I think this is all we need to do, and we need to put it between some quotes. As the second language of your country, very few people on the west coast of Canada know French. Okay, and yeah, let's see if we can get this done. So this command here will replace this one with this other one. And we got root bash here, which is a SUID binary, and we'll be finishing this up in just a second. Okay, we've got birds. Let's put on the birds. Let's see. Where are the birds? Here we go. Okay, so we'll be back in about 20 seconds. I just need to have a little bit drink of water. If you'll notice, these woodpeckers have really long tongues. Anyways, we'll get back to the hacking. Okay, so we've got our root bash. We managed to create it and make it an SUID binary. So to finish the exercise, we just need to execute the root bash with preserving privileges. So we're now root. Okay, we can wander into the root directory and then get the flags. So this is one flag. We'll just submit all these flags to PicoCTF. How many flags do we have left? Okay, so we've got two flags, the etc password flag and then the root flag over here. Anyways, I guess we can do this one, this redeem.
What are you?
I'm system root.
And since we're on Twitch, we can use this emote. Awesome. Okay, so we just need to collect some flags and then we'll be okay. There's probably a flag in the etc shadow file. Yeah, here it is. Okay, did that go through successfully? It did. Okay, and there's how many? So the password file, the shadow file, the root directory, the home directory. So there's like one more flag. Let's check out the home directory. So ETS CTF. Bash logout bash RC profile. So what do they like to put these? So there's two system flags, an app flag, an environment flag, and a root flag. Let's just look for the pattern. So if we grep for the pattern, so grep recursive in the root directory, well, grep recursive in the root directory, look for the pattern ETS-CTF, redirect it into a file called flags.txt, and run it as a background process. And it's funny that even though we're running as root, we still have a bunch of permission denied. Okay. Did you check the export? Which export are we talking about? Okay, there's one here, and then there's like Ansible directory, there's an SSH. There are no keys here. Where else do they like to put these? So environment, export command to see it, export. So env is here. Present working directory is this. So how do we export the root users? Linux export current users env variables. To list or export your current users environment variables in Linux, use the following methods. Export P displays all environment variables in a format that can be used directly as shell commands to recreate them. env is similar to print env. Okay. Export -p. So the actual binary file matches, environment and command line. Binary file matches, permission denied. Temp. Yeah, it only tells me that binary files match. So it might be in the database. grep current directory, grep recursive current directory, pattern, ETS. Ajax loader.gif. Okay, so there's an SQL file in here. File. Oh, it's not here. We actually have a user in here. So mcooper@mail.com. We've got an admin hash, and we've got a staff user hash. I don't think. I mean, we're looking for flags, not passwords necessarily. Okay, let's look back and see which flags we're missing. So we got the password file, we got the shadow file, we've got the root file. So let's see if we can get some hints. Authentication database file. Authentication database file. And root folder, environment variables of the server, and the geckos details. What are the geckos details? Let's see, web server geckos details. Oh, the geckos field is the 5th column of the Linux Unix etc. password file. Okay, so that makes sense. Okay, the root folder, sure. Web service, SSH service. Yeah, we've got these same Gecko's flag, yeah, okay. So the username flag under an authentication database file. Username flag under an authentication database file. Okay, so we found something in etc password. We found something in etc shadow, and that command finished up. And we only managed to find those two. There's no netstat command. There is probably a MySQL that is being run right now, so maybe we can go into the database and get see some more information there. MySQL. Let's take a look at those database credentials. It was in like Database Connect. Was it in the admin directory, I think? DB Connect, yeah. Okay, MySQL localhost opos user. Okay. Joseph Elliott, hello. I'm joining. Are you using a tool or commands in CMD? Yeah, I mean we're currently trying to just get some credentials, not credentials, but just some loot. We need to find all the flags on the system. So does anybody remember? So it's MySQL localhost. Like U? Is it capital U or lowercase u? Oppo user with password. Enter password. It's this one. Access denied. Access denied for Oppo user at localhost. Okay. Oh, I misspelled it. Yeah, okay. You can also try the IP. MySQL-H unknown database localhost. Oh. So that's the database name they're looking at there. Okay, so I will supply the OPOS underscore IP underscore DB. Okay, now we're in. All right, and then show tables. Okay, we got oh man, we got cart, category, list, orders, user info, and users. Maybe user info. Select star from user underscore info. Okay, so this is the user information. And let's just take a look at the other users table. But yeah, thank you, Sticking the Mind. It looks like it defaults to the local host for this particular system. User doesn't exist. Oh, it's users with an S. Okay, we got administrator and staff. Cart, category list, orders, product list, system settings. Maybe the cart. Empty set. So there's nothing in the cart. Category list. Yeah, I mean, we've taken a look at the users table. We're looking for flags, but we've got... Order list, orders. Order list. Nothing here. Here we go. Here's the flag. Okay, so we'll submit this, and then there's one more to go. I mean, I'm not really too sure where to look after this. Unless this is the last flag, in which case we're good. Okay, gonna have to go back and watch the exercise again. Yeah, you're welcome to. Okay, so there's one more flag, we just need to guess where it is. So, authentication database file, I think we found this. We found the root flag. We found... where are the environment variables of the server? So maybe the, like, Apache? Where are... Where are the environment variables stored in Linux? I mean, we tried just looking at our env. That didn't quite work out. Oops. User bin env. User bin env. Wait, is that a file or a directory? Okay, and how do we... What is the typical way we interact with the user bin env file? Print env? User bin env file. So there's got to be some special way we interact with that file, right? Linux user bin env. I mean, env is the binary that shows you your environment variables. I mean, we could maybe run strings on it. And then search for the pattern. Nope. This last flag is just, it's taunting me. Okay, Gecko's details, authentication flag on the web server. Authentication flag on the web server. So I'm pretty sure we didn't find a web server authentication flag. So maybe we need to go back and take a look. So here we are, here's the web server. What other users? I mean, the other users, we've investigated the other users, we weren't really able to find anything. So maybe read like login.php. In the PHP code. Grep recursive current directory pattern ETS. Binary file matches. I mean, why would this match? It seems weird. Maybe we need to be more specific. We weren't able to find anything, okay. Okay, we're able to find... So the shadow file has a flag, the password file has a flag. Authentication flag on the web server. What about home.php? Cat star .php. So these are all the PHP files. We'll grep out ETS. Nothing here. The admin directory, we'll try the same thing. Yeah, I'm not too sure where this last flag is, jeez. Let's try taking a look at the actual website. Unless it has something to do with the admin user and it getting actual access to the admin user. So the database is here. Let's grab the administrator password hash. So this is it. So what kind of hash is this? What kind of hash is this? So this might be, oh, bcrypt, okay. Hash ID? I mean, there's a bunch of different ways we could try it. So hashcat mode 3, 3200 for cracking. Total length, always 60 characters for PHP bcrypt. So we would run... I haven't run hashcat in a while. Here we go. Okay. So you got hashcat on some file. And let's make a file for this. Admin.hash. Well, we don't need the quotes for this. So it's 30, so it's admin.hash. And we're looking at, what is it, 3200? Okay, so we got a hash cracking attack happening over here. There's a hash ID command that helps identify the hash type. Yeah. It's just that sometimes it's just easier to just throw it to the AI. Okay, so we're over here. Okay, so this is the website. We've got the administrator login over here. So the username and password. The other thing we could do is we could take a look at this other user as well. So the other user is the staff user. Anyways, I should probably get going pretty soon. Let's take a look. Still fuzzing here. Alright, I'll try to do a write-up for this machine and post it up to my GitHub when I'm finished. But in the meantime, let's see if there's any cool people over at infosecstreams.com that we could raid into. So infosecstreams.com is a website where you can see cool people who are doing cybersecurity and live streaming. So is B Theo on right now? Let's just check this out. It looks like Hack Smarter might be on. That's weird. Let me give that a look-see. Oh, Hack Smarter is on. Awesome. Yeah, let's raid into his channel. Okay, we'll set up the raid. Alright everybody, when you arrive on HackSmarter's channel, if you could give this raid message, I'd really appreciate it. So it's OSFrog, Hip Hop Hack, OSFrog, just like this. We also are going to stream one more time this week on Friday. We're going to be covering AI basics. We're going to be taking a look at HackSmarter. We're actually going to be taking a look at HackSmarter's Windows AD machines. So that's going to be on Friday. Stay tuned for that. And in the meantime, everybody say hi to HackSmarter for me, okay? Alright, HackerFrogs ready to raid in 5, 4, 3, 2, 1. See you on Friday, everybody.